Hello, my dear class 10 students. How are you all? How's your preparation going? Hello, everyone. Yep, Glam Confessions. I see you are waiting. Your wait is finally over. Okay, so today what we are going to do is we are going to complete chemistry in just one lecture. Okay, this is going to be long live. Okay, so be prepared. I have complete chapters along with lots of questions that we are going to practice, all competency based, NCRT questions, new pattern based questions. Okay, good morning Divyanshu, good morning everyone. How is your morning going? Well, firstly, tell me, let me ask you something. How was your English exam? How was your math exam? What are your thoughts on, like, how are your exams going till now? Are you managing just fine? Yes, on time. Good morning, Glam Confessions. Okay, so, yeah, do tell me, how are your exams going? Maths was hard, but English was easy. Okay. So, see, many students were worried that they are going to lose marks because math was hard, but your English was comparatively easy. And coming forward, I believe if you properly prepare and if you get, it was your first exam. You did not know what will be coming your side. Okay, so yeah, it happens. But now you are prepared. Now you know what can happen. You know the worst and you know the best also. So you can score good marks in your upcoming boards. Okay. Oh, it's okay, Divyanshu. You have other subjects to cover for, okay? What I heard was maths paper was really difficult. Yeah, everyone is agreeing. So, was it just 2-3 questions or was the whole paper so hard? Were it just 2-3 questions that were like little tougher, or was it the whole paper? All the questions were hard, huh? Was it like that? Okay, so let's begin from the first chapter, chemical reactions and equations. Math KG level. Oh, every question was new. Yeah, because they changed the pattern this year, but what I'm asking is different. I'm asking if was 4-5 questions were hard or the whole paper was hard, because you were not able to solve the whole paper. Hi Priya, Sai Priya. Hi Sai Priya. So let me start from the first chapter. Very good. Chemical reactions and equations. Okay, this is our first chapter. Okay, now in chemical reactions and equations, now what is a chemical? Now what is a okay? I need to just okay. So let's start. What are chemical reactions? So chemical reaction is a process in which one or more substances, basically you have reactants and products, right? Your reactants gets converted into products. That is a chemical reaction, right? It is a process in which one or more reactants get converted into product. Okay, now there are some characteristics of a chemical reaction. Basically, if this is happening, then it is called a chemical reaction. What are those characteristics? We will discuss them. Now the substances that are reacting, they are called reactants. The substances that are produced at the end are called products, right? Very simple. If you have, let's see if you have A plus B, these are reactants, they combine and give product C plus D. These are your reactants and these are your products. Very basic. Okay, this is one reaction. So these zinc and sulfuric acid are your reactants, and zinc sulfate and hydrogen gas that is produced is product. Now I told you about characteristic, right? What are the characteristic of a reaction, chemical reaction? So these things are happening, then you identify that yes, there is a chemical reaction happening. What are those? First is evolution of gas. Whenever in a reaction, whenever some reaction is happening, some process is happening, and in that there is evolution of gas. For example, in this reaction, when zinc combines with sulfuric acid, we get zinc sulfate and hydrogen gas is evolved, Now this is evolution of gas, so that identifies as a chemical reaction. These processes identify as a chemical reaction. Next, formation of precipitate. Whenever there is a formation of precipitate, what are precipitate? These are insoluble salts. What are precipitates? They are insoluble salts. Okay, formation of precipitate also indicates that there is a reaction happening. Okay, next, change in color. Whenever you observe a change in color, that also means there is a reaction happening. For example, here copper sulfate combines with iron. Just tell me quickly what will be the color change. See, in here copper sulfate is blue in color, iron is brown in color, right? Iron sulfate is green in color and copper is again reddish brown in color. Now, whenever there is a change in temperature, if a chemical process is happening and in there is a change in temperature, either exothermic or endothermic, that also identifies as a chemical reaction. Change in state. Whenever there is a change in state, for example, when you burn a candle, where did the candle go? The wicks melted, right? But in general, you have liquid candle, solid candle, right? And when it melts, what we get? We get carbon dioxide and liquid. Okay, so we had the change in state, right? We had solid candle and it got converted into liquid, wax plus gas, right? Carbon dioxide. Okay, I hope it is clear. They don't. Okay. Combination reaction is a chemical reaction, they don't for precipitate. So that is one type, no? Combination is just one type of reaction. Precipitation comes under the displacement reaction category, okay? Precipitation reactions comes under the displacement reaction category, double displacement, okay? That's a different thing. Okay. Now, what are chemical equations? We were talking about chemical reactions till now. What are chemical equations? So, chemical equations are just a shorthand way of representing a chemical reaction. Yes, they are just a shorthand method. What do you mean by shorthand method? For example, we know my name is Ekta, right? And let's say your name is Yov, right? So, how do you write it? How do you represent it? You will represent it like this, no? Or no, like this, right? So the thing is, this is just a representation. This is just a way of representing our name, writing, okay? So similarly, you write chemical reactions by using chemical equations. That is just a shorthand way of representing chemical reactions. For example, there are majorly there are three types. You have word equation. In word equation, you write using words. For example, this reaction, if I write using word zinc combines with sulfuric acid, we get zinc sulfate and hydrogen, right? Simple. And then you have skeletal equation. What is skeletal equation? So you just change whatever word you have written, you write their chemical symbol. Simple. Whatever word you have written, whatever chemical name you have written, you just write their chemical symbols, and that is a skeletal equation. Okay. Then you have balanced equation. A balanced equation is that equation which follows law of conservation of mass. What is law of conservation of mass? That is, mass can neither be created nor be destroyed, but can only be transformed from one form to another. What that means in chemical reaction context is that if two reactants are combining, let's say 1A and 1B are combining, then you will get how much? 2 mole. Let's say you get 2 mole of AB. Okay, 2 mole of AB. No, sorry, 1 mole of AB. You will get 1 mole of AB. So the amount of A and amount of B will still remain same. The number of reactants combining will be equal to the number of products formed, because obviously the amount that you are giving, only that amount you will get, right, in chemical reactions. Good morning. Good morning. Hello. Okay. And now you can add more information. Now you can add more information to a chemical reaction, a chemical equation. How do you add that? You represent the physical state. For example, if your reactant or product is solid, you write S. If it is liquid, you write L. If it is gas, you write G. And if it is aqueous, you write AQ. Okay. So that is written to give more information. For example, here zinc is solid. Sulfuric acid is aqueous. That means it is dissolved in water. It is an aqueous solution. Zinc sulfate is also aqueous and hydrogen is gas. So it is written there. It gives more information. When you want to get more information from a chemical equation, you write these physical symbols, physical state symbols. Okay. Now, how do you balance a chemical equation? Okay, this is just the procedure, but let me start with a reaction. Simple one, should we pick? What should we pick? You want a tough one or simple one? Hello everyone. Do I remember? Okay, let me start with this one. Okay, we need to balance this reaction, right? So we will go step by step. Okay, let me see. Give one that I can impress the examiner. Medium. Hit and trial method, yes. Tough. Tough. You want really tough? I'll give you one for homework. Okay. But for now, let's start with the medium level one. Okay. So see, iron combines with oxygen, we get iron oxide. Now we need to balance this. Firstly, check. Make this table if you want. This is very easy. You just make a table. Let me just write. We have iron. Okay. Let me just. Okay. I'll write here. Fe2O3. Okay. Write Fe one side, oxygen on the other side. Let's write reactant here and product here. Okay. So in reactant, how many iron we have? 1. In product, we have 2 irons. In reactant, we have 2 oxygen, and in product, we have 3 oxygen. So start with the iron first. Okay. Remember, start with your metals, non-metals, then hydrogen, then oxygen. Okay. This should be your sequence. Metals, non-metals, then hydrogen, and finally oxygen, because sometimes what oxygen is a little complicated to balance. Okay, if you start from there, you will get more confused. So start with metals, then non-metals, then hydrogen, and then oxygen. So let's start with the metal first. We have 1 iron on the reactant side, 2 on the product side. So what we will do, simply multiply the reactant by 2, and thus the number is balanced. So just write here 2. Now see, iron is balanced. Okay, what about oxygen? Now let's try to balance oxygen. We have 3 oxygen here, 2 oxygen here. So what we will do, we'll cross multiply. 3 here and let's say 2 here. Let's say 2 here, 6 here, 3. Now the number of iron is unbalanced again. So what we will do, here see, the number of oxygen is balanced, 6 on this side and 6 on that side, but the number of iron is not balanced. So what we will do, we will again multiply. Now we have not this, we have 4 iron in the product side and only 2 on the reactant side. So again you multiply it by 2, simple. And 2 times 2 means 4. So we just replace it by 4. This is your balanced equation. Okay, let me just write it. 4Fe3O2, 4Fe plus 3O2 gives 2Fe2O3. And yes, if you want a tougher one, I'll give you a tougher one. This is the balanced equation, okay? Hi, Sagar. 3232, yes. 432. Who is writing 32? Okay, then where is the 4? 321? No. No, you've incorrect. I don't know. Hey, hold on a second. No, I did put Fe2O3 only. Where did I put Fe3O2? It's Fe2O3, both sides. Okay, now let's see one example for your homework. C3H8. It is combustion of hydrocarbon. CO2 plus H2. Okay, balance it. Balance it and then give me the answer. I don't know. I put Fe2O3 only because iron, the oxide that we study is Fe2O3, not Fe3O2. Okay, balance this one. Simple step is you start by making a table. Just a trick I'm telling you. Start by making a table. Write the elements you have on one side and reactant and product, and then start by balancing from this table only. Okay, very easy. We started from iron. We had 1 iron, and on the product side we had 2 irons. Okay, so we balanced the iron first. Remember the sequence: start from metals, then non-metals, then hydrogen, then oxygen. Okay. Then after that, what we did, we see that number of iron is balanced, but number of oxygen is not balanced. So we cross multiplied. 6 oxygen on the reactant side, 6 oxygen on the product side. Now oxygen is balanced, but iron is not balanced. So what we will do, we'll try to balance it again. We have 4 irons on the product side and only 2 on the reactant side. So we multiplied it by 2, and 2 times 2 equals to 4. So that's how you balance it. Hit and trial you say it, but if you make a table, a pencil table somewhere in your rough work also, it will help you. You can balance any reaction. See, it was C3H8. Again, are you not able to see? C3H8 plus O2 combines, gives CO2. Yeah, that is, yeah, I'm gonna go jail if I do that. Plus, I did not make the paper, no? Fe3O4 you want. Okay, you can put it and then tell me the answer. What is your answer? You're at C8H8. Where is it? C8H8. That's not how you do it. Anyways. Okay, I'll do it before starting the question. C3H8 plus O2. Let me just click a picture so that I'll remember. Okay. Three, nice. 8, okay. 6, 10. Done. That is balanced. Yes, you don't multiply. You did C8H8, so I got confused. Don't, as you initially put that before F8. Okay, let's move on. What are the type of chemical reactions? Okay, we have combination reaction where 2 or more reactants combine to give single product. Then we have decomposition reaction. In decomposition reaction, again, single reactant breaks down into multiple products. Single reactant breaks down into multiple products. There are 3 types of decomposition. You have thermal decomposition, that is you do using heat. Then you have electrolysis, which is decomposition. You are doing decomposition using electricity, right? And then you have photolysis, which is decomposition is done using sunlight. Okay, these 3 are the examples, commonly used examples. When you do electrolysis of water, you get hydrogen and oxygen. Hydrogen is obtained at cathode and oxygen is obtained at anode. You will remember it easily because there is O, oxygen, anode, there is O in anode and there is oxygen which obviously has an O. And then in cathode you have H, hydrogen and cathode. Photolysis is, it's a common example. This is used in blue and black and white photography. Decomposition of AgBr, silver bromide. We get silver and bromine gas is released, right? Then you have displacement reaction. What is displacement reaction? When a more reactive element displaces a less reactive element from its compound. Okay, so here zinc is more reactive than copper. So zinc will displace copper from its compound copper sulfate, and that's why we get zinc sulfate and copper. Then you have double displacement. This is single displacement. Single element is displacing the other element from its compound, right? But in double displacement you have the exchange of anions, exchange of ions between the reactants. Here see, if you see here, sodium, there is exchange of ions between sodium and barium, right? You get barium sulfate and sodium chloride. Again, this is an important reaction. It has been asked 2-3 times in your boards. Then you have exothermic reaction, endothermic reaction. Exothermic means when you are doing a reaction and there is lots of heat and energy is released. Lots of heat and energy is released. It is exothermic. Endothermic means the reaction absorbs lots of heat and energy, okay? Absorption of heat and this emission of heat, you know, release of heat energy and absorption of heat energy. Exothermic and endothermic. Yes, it was. Okay. Next, oxidation and reduction. What is oxidation? Oxidation is addition of oxygen or removal of hydrogen. If either of these condition is there, you call it oxidation. Then you have reduction. Reduction is addition of hydrogen or removal of oxygen. Addition of hydrogen or removal of oxygen. Okay. These are some of the important chemical reactions. You can go through them, take a screenshot of it. This is from chapter 1. Okay, so this is rusting. The first reaction is what? This is also a double displacement reaction. This is an example of double displacement reaction. Okay, now what is this example? This is an exothermic reaction. Quicklime, when you add water to quicklime, you get slaked lime. Okay, then again this slaked lime water, it is also called lime water. And when lime water, you pass carbon dioxide gas through lime water, it turns milky. Milkiness is due to calcium carbonate. Milkiness is due to calcium carbonate. Okay. Now, prolonged passage you can do. If you prolonged passage, you know, if you pass carbon dioxide gas for too long, it will get converted into calcium hydrogen carbonate or calcium bicarbonate. This is water soluble. This is soluble. So, the milkiness disappears. The milkiness disappears. Next is thermal decomposition. This is thermal decomposition of lead nitrate. It gives lead oxide, nitrogen dioxide and oxygen. Nitrogen dioxide is brown in color, so that's why you get the brown fumes of nitrogen dioxide, reddish brown fumes of nitrogen dioxide. Then you have these decomposition reactions, which is a decomposition of silver chloride and decomposition of silver bromide, and you get silver and chlorine gas, silver and bromine gas. The color changes from yellow, or this is white. Color changes from white to gray. This is white and this is gray. Silver is gray, right? Next is, this is an example of displacement reaction. Iron combines with copper sulfate, you get iron sulfate and copper. Sodium sulfate combines with barium chloride, you get barium sulfate and sodium chloride. Again, this is an example of precipitation, or you can say double displacement reaction. Okay, copper combines with oxygen, copper oxide is formed. What is the color of copper oxide? Black in color. Copper, this is an oxidation reaction. Next, this is also oxidation. This is a formation of rust. Okay. I hope you took a screenshot of it. Next process is corrosion. What is corrosion? So, corrosion is the process of degradation of metal. You have pure metal, and with time, its exposure to air and moisture, it gets converted into its oxide, sulfide, hydroxide, right? That is corrosion. When you had pure iron but it gets rusted, but it gets converted into a different compound, hydrated iron oxide. What is rust? Hydrated iron oxide, right? So basically metals get converted into their oxides, sulfides, hydroxide. That is called corrosion. Okay. Now for example, copper. When copper gets corroded in presence of carbon dioxide, what it gets converted into? Copper carbonate. It gets converted into copper carbonate. What is the color of copper carbonate? What is the color of copper carbonate? What is the color of copper carbonate? Copper carbonate is green in color. Okay, so if you have seen copper vessels lying around and if you do not use them for too long, they get this green coating on them. Green colored layer will be formed on it. That is copper carbonate. Okay, that is due to the corrosion of copper because of carbon dioxide. Okay. Silver articles turn black when exposed to air. Why? Because silver gets converted into silver sulfide. Silver gets converted into silver sulfide. So that is because of the action of sulfur present in air. Because of the action of sulfur present in air. This is silver sulfide. Now how do you prevent corrosion? You prevent corrosion by coating. So if you coat your metal surface, metal object with any paint, with any acrylic, anything you cover, so it will prevent the contact with the air and moisture, and that's thus prevent the corrosion. Okay. One more is there, galvanization. What is galvanization? So in galvanization, you apply a coating of zinc on the surface of iron. Why? Because zinc is more reactive than iron. As we will see in the reactivity series, zinc is more reactive than iron, so it will get corroded and your iron object will be safe. Okay. If you have any doubts in these chapters, we are doing chemical reactions and equation, ask them. Okay, I'll answer your doubt. Because this is complete chemistry today, so we'll finish it from start to end. Rancidity. What is rancidity? So rancidity is the oxidation of oily and fatty foods. Oxidation. Oxidation means addition of oxygen, right? There is something happening with oxygen. Addition of oxygen. Oxidation of what kind of foods? Fatty or oily foods, due to which your foods get this unpleasant odor and taste. Okay, that is rancidity. Now how do you prevent rancidity? Firstly, you should never consume rancid food. Okay. Second, how do you prevent rancidity? You prevent it by storing them in airtight containers. When you store food, oily or fatty food, in airtight container, you are preventing these oxygen, direct supply of oxygen, right? And cutting that supply of oxygen means you are preventing them from going rancid. Okay. Next is refrigeration. Again, when you lower down the temperature, the bacteria won't work, oxidation won't happen at lower temperature. Flushing with nitrogen. Again, if you're replacing oxygen with nitrogen in place of oxygen, if nitrogen is there, no rancidity will happen. Okay. Now, we have the questions. That was all. We have the questions now. So tell me, a dilute ferrous sulfate solution was gradually added to the beaker containing acidified permanganate solution. Acidified permanganate solution. I'll write the reaction, FeSO4. Okay. And permanganate means okay. The light purple color of the solution fades and finally disappears. Which of the following is the correct explanation for the observation? Just tell me, it is alkaline, is it acidified permanganate? So what has happened? The color has faded. What reaction is happening? Good morning. Hi. Firstly, Arambian, right? You were, I remember you were a very good student. What happened? What happened? Okay. A. Answer is A. Okay. See, I think you're lying. You are very good at chemistry. I have seen you. Like in the live class, I've seen you. You were able to answer each question correctly. What happened now? Yes, the answer is A. Okay. I don't know. I remember in the last class you were quite attentive. So FF Gamer, I have made a video about color of all the important chemicals. You can go check it out. Yes, what was your message? So yes, as we know, acidified potassium permanganate is a good oxidizing agent. So which is the statement you think? It is a good oxidizing agent. And oxidation means this iron sulfate gets oxidized to, this is Fe2 positive. It gets oxidized to Fe3 positive. Hold on a second. Yes, KMnO4 is used as an oxidizing agent only. Don't say that. What is your message? Please just tell me. So I hope FF Gamer you can study now. What is, I can't find it. Just tell me please. Okay, Arambian, don't worry. What is, you don't understand anything? Do you not, like, up till now, whatever I've taught you, chemical reaction and equation, did you not understand anything? Can you name the other oxidizing agent? Yes, you have two actually. Acidified potassium dichromate. These are the two oxidizing agent, acidified potassium dichromate and alkaline KMnO4, alkaline potassium permanganate. These are the two oxidizing agent that you use in carbonates compounds. Okay. Glam confessions, what was your question? I did not get it. And Arambian, yes. Okay, so yes, iron sulfate gets oxidized to Fe3 positive, okay, because it is a good oxidizing agent. So the correct answer is it is an oxidizing agent. It oxidizes iron sulfate to Fe3 positive, okay. That is the correct answer. then take a break. Take a 5-minute break and then start again, okay? It's human psychology, you know. We have less attention span because of social media, because of phones and everything. So do one thing, if you're studying for 30 minutes, wait for 5 minutes and then start again. You will understand it. Okay, I hope your doubt is answered. Next question. Which of the following reaction is categorized as thermal decomposition? Thermal decomposition means, again, you are using heat to decompose. Heat to decompose. Which reaction uses heat? Which reaction uses heat? D. Yes, decomposition. Thermal decomposition, yes. Correct, okay. FF Gamer, that is a very bad advice you are giving. Don't do that. Okay, correct. So yes, when you are doing decomposition of water, we are using electricity. We are using electricity. When we are doing decomposition of silver bromide and silver chloride, we use sunlight. We use sunlight. And when we are doing decomposition of calcium carbonate, we use heat. We use heat. That means thermal decomposition. That means thermal decomposition. Actually, no. Yes, correct answer is D. Correct answer is D. Yes. Glam confessions, maybe you are using some words. Yes, D is the correct answer, Anikesh. Okay, so I still didn't get your question, Glam confessions. I still did not. I'm scrolling, but I'm not finding any comment of yours. Nope. Next question. Assertion says burning of natural gas is an endothermic process. Burning of natural gas is an endothermic process. Reason, because methane gas combines with oxygen to produce carbon dioxide and water. See, when you are doing assertion and reason questions, remember one thing. Whenever you read the assertion, add a because and then say your reason. If it makes sense, then it is correct. But here we see, when you burn natural gas, it is an endothermic process. It is not an endothermic process, right? When you burn natural gas, methane is a natural gas. If you burn methane, we get carbon dioxide, water, and lots of heat is released. That is an exothermic process. Endothermic means heat is absorbed. Reactants are absorbing heat. But exothermic means heat is released. Okay, heat is released after the reaction. So yes, the assertion is incorrect. Assertion is incorrect. What about the reason? Methane gas combines with oxygen to produce carbon dioxide and water. Yes, that is correct. Methane gas is combining with water to give carbon dioxide and water. So that means, what is the correct answer? Assertion is true and reason is false. Assertion is true and reason is false. Sorry, assertion is false and reason is true. The correct answer is D. Yes. Correct. Hello, multiverse. I don't. Yes, what is your name? Okay, next question. A student took sodium sulfate solution in a test tube. This is sodium sulfate. And added barium chloride to it. He observed that an insoluble substance, that means a precipitate, is formed. The color and molecular formula of the insoluble substance. So we will get barium sulfate and sodium chloride. This is the precipitate. What is the color of this precipitate? Gray or white? Tell me. Correct, Divyanshu. Okay, yes, the color is white. And we get barium sulfate. The precipitate, the insoluble substance is barium sulfate. And that's why, and the color is white, okay. Again, if you have any doubt regarding the these colors and the important chemical formulas. Okay, there will be a PDF in the description, you can find it and you can download it. There we have combined all the biology diagrams, all the physics formulas, all the chemical reactions, important chemical reactions from chemistry, right? And there's one more video we have that I have made for color of all the important chemicals. It has all the important chemicals color, okay, that are in your 10th class. You do not need to go beyond that. Everything is covered there. You can check it out if you have problem remembering the color of compounds, okay. We have time, we still got it, we can do it, okay. Correct, Anikesh. Be white. That I don't know. What will CBSE do? Next question, which of the following statement about the reaction below is incorrect? Look at the question. Incorrect statement we are asking. So lead oxide combines with iron, we get lead carbon and we get lead and carbon dioxide. Okay, so let's see. Lead oxide is getting converted into lead. Okay, so is it oxidation or reduction? Is it oxidation or reduction? Yep, Divyanshu, we will teach you all together. Do not worry, we are with you. If you have any doubt, if you do not understand chemistry also, just start from somewhere, okay. Start with metals and non-metals, start with carbon and its compounds, give your all, because still 25 you have to study. After that you will be given some break, I think. Next paper is of Hindi or SST straight away, right? Yes, so lead oxide is getting converted into lead, that is reduction. And carbon getting converted into carbon dioxide, what is that? Oxidation, right? That is oxidation. Now just look at the options one by one. Lead is getting reduced. Nope. Even if you go backside, even if you go from here to here, lead is getting converted into lead oxide. But obviously the reaction is going in one direction only. Let's see, lead is getting converted into lead oxide. So obviously it's oxidation, not reduction. That is wrong. Carbon dioxide is getting oxidized. Carbon dioxide is not getting oxidized. Because if you go back also, carbon dioxide is getting converted into carbon, which means it is getting reduced. So this is also incorrect. Carbon is getting oxidized. Yes, carbon is getting oxidized. Correct. And lead oxide is getting reduced. Yes, lead oxide is getting reduced. So that means the correct answer is yes. 27. So the correct answer is C and D. Incorrect statement you needed to identify. Oh, incorrect. A and B. So the correct answer will be A and B. We needed to identify the incorrect statement. Lead is getting reduced, that is incorrect. Carbon dioxide is getting oxidized, that is also incorrect. So the correct answer is option A. C and D are correct, yes. Don't study too much, you are gonna top your boards. Lead is oxygen, then lead is losing oxygen, then it won't be reduction. Since lead is losing oxygen, it won't be reduction. Won't it be reduction? So yeah, it is reduction. Where are you going with this? I am telling, the green shows the forward reactions. Okay, I'm talking about lead oxide getting converted into lead, carbon getting converted into carbon dioxide. The red arrows show the backward reaction, because it said na lead is getting oxidized, getting reduced. So I showed you that lead is getting converted into lead oxide. That means it is getting oxidized. That statement you are saying is correct. Yes. Okay, so the correct answer is 1, option A and B. Okay, you did not understand it. Yes, yeah, too much for you guys, I know. You don't know oxidation reductions. Okay, let's start. One more time I'll explain, no problem. Lead oxide is getting converted into lead. That means we are losing oxygen, and loss of oxygen is called reduction. Carbon is getting converted into carbon dioxide. That means addition of oxygen. Addition of oxygen, oh, that is oxidation. That is oxidation. Right? Now see, lead is getting reduced. Is lead getting reduced? No, lead is not getting reduced. This is talking about lead. One more thing, my dear students, we are talking about lead. We are not talking about lead oxide. It has a name. It is not lead. It is lead oxide. Lead is getting reduced. Is lead getting reduced? No, it is not. It is there in the product only. No reaction it is going under. Carbon dioxide is getting oxidized. No, it is not. Carbon dioxide is there in the product only. No reaction is happening with carbon dioxide. So both are incorrect. Carbon is getting oxidized. Yes, that is correct. Carbon is adding oxygen. One more oxygen is added to carbon and we are getting carbon dioxide. Lead oxide is getting reduced. That means lead oxide we have, it is losing oxygen. Yes, it is losing oxygen and getting converted into lead. So, yes. Okay, just go this way. We need to identify the incorrect statement only. So, the incorrect statement was option A. Option 1, A and B are incorrect. A and B are incorrect. Okay, I hope your doubt is clear now. Next question, what happens when dilute hydrochloric acid is added to iron fillings? So, this is iron, and if we add dilute hydrochloric acid, what will we get? Firstly, this is a metal and this is acid. When metal combines with acid, we get what? I'll tell you, we get, now tell me in the, actually you tell me, what do we get when metals and acid combine? What do we get when metals and acid combine? We get salt and hydrogen gas. We get salt and hydrogen gas. Okay, so when metal and acid combine, we get salt. The salt will be iron chloride and hydrogen gas will be released. So let's see which option, hydrogen gas, iron chloride. Yes, that is correct. First option is correct. Iron, salt, water are produced. No, no reaction takes place. Reaction is happening. Chlorine gas and iron hydroxide are produced. Nope. Salt and H2, correct. Salt and H2, correct, Anikesh. Okay. The correct answer is option A. Let's move on to the next question. Which of the following is not a physical change? Not a physical change. Okay. That means we are looking for chemical change or something, right? If you boil water to give water vapors, water is getting liquid, right? And it gets converted into gas. But if you cool down those vapors, you get the liquid again. If you cool down those vapors, you get the liquid again, right? So is it a chemical change or a physical change? It is a physical change. There is only change in the physical state. What are physical states? Solid, liquid, gas. If there is change in these states, solid is getting converted into liquid, liquid is getting converted into gas, water, right? Ice to water vapors. That is a physical change, okay? But if a different compound is getting formed, right? If you have a, let's say if you have a reactant and it gets converted into a different product, a different compound, that is a chemical change because a new chemical is formed, a new compound is formed, right? Okay, so melting of ice to give water, again melting of ice to give water, this is also a physical change. Dissolution of salt in water, combustion of liquefied petroleum gas, not a physical change. Yes, the correct answer is D, because when you combust liquefied petroleum gas, LPG, this is LPG, and when you combust it, which means you provide oxygen to it, we get carbon dioxide plus water plus heat and light. So just see, we had methane. Methane got converted into carbon dioxide. That is a different compound. Methane is a different compound. Carbon dioxide is a different compound, right? So that is not a physical change. That is a chemical change. That is a chemical change. Yes, the correct answer is yes, the correct answer is D. Next question. Which of the following are an endothermic process? Endothermic, that means energy is getting absorbed. That means energy is getting absorbed. So FF gave my it is of 25 marks only. Okay, so endothermic means you are providing energy. We are giving energy to the reaction. Okay, dilution of sulfuric acid. When you dilute sulfuric acid, I don't know if you've done it in your labs or not, but firstly we add sulfuric acid dropwise to water. We add sulfuric acid dropwise to water. Why? Because it is a highly exothermic reaction. Lots of heat is released. Sometimes if you that's why it is advised not to add water to acid. Why? Because the reaction is so much exothermic that you might spill the acid, you might get burned. Okay, so that's why it is not advised to add water to acid. Instead, what we do, we add acid to water, which is dropwise. Okay, so what we have water here, and we add acid dropwise. Why? Because this process is highly exothermic. Okay, next, sublimation of dry ice. Sublimation. Oh, sublimation, you know, when solid gets converted to gas. Okay, when solid gets directly converted to gas without converting into liquid state, right? So solid to gas is going. Okay, sublimation of dry ice. Okay, condensation of water vapors, evaporation of water. So when you condense water vapors, what are you providing? Heat. Evaporation, this is 1 and this is 1, 2 and 3. No, don't have the answer. Yes, C, D. Okay, so when you evaporate water, okay, condensation means you have vapors and you are lowering down the temperature, right? You are lowering down the temperature. So it is not an endothermic reaction, right? When you are evaporating, you are providing the energy. When you are evaporating, you are providing the energy. You can't add acid to water. We could explain why we can't add water to acid. You can't add water to acid because it is a highly exothermic reaction. If you add acid to water, if you add water to acid, the acid might spill because the reaction is so much exothermic. Lots of heat is released, right? So the acid might spill and you might get burned. The vessel can get cracked. You know, the glass vessel can get cracked. So that's why we do not add water to acid. Instead, what we do, we add acid to water, which is dropwise, because then you have the control. You are adding drop by drop. The temperature is rising slowly, right? In a linear manner, it is rising slowly. Okay, and the vessel does not crack then. Okay. Okay, so when you are doing sublimation, when you are converting a solid directly to gas, you heat it. We heat it. That means we provide energy, we provide heat to it. The reaction is endothermic. Okay, when you are condensing vapors, so water vapors have temperature greater than 100 degrees Celsius, and when you are condensing it, you are bringing the temperature down. That means energy is not getting absorbed. You are releasing the energy, and when energy is released, this process is called exothermic process. And when evaporation is done, when you are evaporating water, you are increasing the temperature. That means you are providing the energy. How do you increase the temperature of water? You heat it. Heat means you are providing the energy, right? That means it is endothermic. You are providing the energy. Energy is getting absorbed. Heat is getting absorbed, right? So the correct answer is option D. Next question. Good morning, Ayush. Column 2 gives the type of reaction mentioned in column 1. Match them correctly. It's a different one. Here we have products actually. Column 2 we have product. And column 1 has the reaction. You need to figure out which product will be obtained. When you do decomposition of KClO3, zinc carbonate, hydrogen carbonic acid of ethane. You answer it. So when we do a decomposition of KClO3, we get oxygen gas. Zinc carbonate, we get carbon dioxide. H2CO3, carbonic acid. We get H2O and CO2. Correct. And when you heat ethane, what happens? For D, water. When you heat it, we get carbon dioxide and water. So for A, the answer is P. Let's see which option has P. It is either option A, it is either option B. Okay, next let's say for B, zinc carbonate, we get zinc oxide, yes, plus carbon dioxide. We get zinc oxide plus carbon dioxide. So that means Q and R, S and R. Okay, it got a little confusing here. Let me rewrite it. You need to match the product with the reactants. So when you have KClO3 and when you decompose it, what do we get? Oxygen gas we get actually, plus KCl. Okay, so oxygen gas is present. So for A, the correct answer is P. We have two options, A or B. Now see, zinc carbonate, when you decompose zinc carbonate, you get zinc oxide plus carbon dioxide. Okay, so that means for B, the correct answer is R and S. So that means this is your correct answer, option A, right? For C also, carbonic acid, when you decompose carbonic acid, you get water and carbon dioxide because this is what is made up of. And then you have ethene, and when you heat ethene, you get again carbon dioxide and water. Okay, so basically you do not need to know the answer of all the questions, all the options. What you need to do is you need to just know a few so that you can cross check. For these kind of questions, this strategy works fine. Do you guys have any doubts? Next question. Solve this question. See, assertion says a reaction in which a single reactant breaks down to give simpler products single reactant breaks down to give simpler product. Single reactant breaks down to give simpler product is known as decomposition. Yes, that is a decomposition reaction. That is true. Reason says these reactions are always exothermic. Now see, we have combination reaction, we have decomposition reaction. When combination reaction is happening, you have more than one reactants combining to give a single product. That is a combination reaction, right? So when products are combining, you're forming something, energy is released. These kind of reactions are generally exothermic. I don't know if you know it, but when two atoms combine, they form a compound, they lose energy. Only then the product is formed. Why? Because if I am already stable, if one atom is already stable, it won't react, right? I am unstable. That's why I am reacting. If this atom reacts and form a compound, that means a lot of energy is lost. Energy is lost, or energy is released in this case, okay? When energy is released, that process is called exothermic, okay? For decomposition, you have a single reactant. If you have a single reactant and it breaks down into multiple products, okay? So here what is happening, bond is, you are breaking the bond between C and D, and whenever you are breaking something, you need to give energy. Always remember it. So decomposition reactions are generally endothermic because you are giving energy to it. They are endothermic. Okay? Now see, decomposition reactions are generally endothermic. Why I am adding generally? Because there are some exceptions. Always will be. Okay, so that's why we use generally. That for 90% it is true. There are some reactions which are exceptions. Okay, so generally combination reactions, when two atoms combine to give one single product, they lose lots of energy. Lots of energy is released. That means these reactions are generally exothermic. For decomposition reaction, single reactant breaks down into multiple products, right? When you are breaking a bond, you need to give energy. That means energy is absorbed. These reactions are endothermic. Okay, so here assertion is true, that is decomposition reaction. Reason is also true, always exothermic. Yes, they are always, no, they're not exothermic. Reason is false because decomposition reactions are endothermic. That too generally, not always. Sometimes there will be case when a decomposition reactions also release energy. Okay, that also happens. So the correct answer is assertion is true but reason is false. Assertion is true but reason is false. Decomposition, compost of, you have seen now when you do composting, right? You have all the fruit peels and all the natural biodegradable waste, and you dump in the ground and you try to make manure out of it. That is a decomposition reaction, but it is exothermic because it releases energy, right? Okay. Yep. Assertion says a reducing agent is a substance which can either accept electrons, and reason says a substance which helps in oxidation is known as reducing agent. Answer this question. Endothermic reaction. Electrolysis of water is endothermic reaction. C. A reducing agent is a substance which can either accept electron. Statement. What is a reducing agent? A reducing agent is a substance which reduces other and gets oxidized itself. Which reduces others and oxidize itself. Reduction means gain of electrons. Okay, reduction means gain of electrons, oxidation means loss of electrons. Okay, so it is a substance which can accept, no, it can donate electrons. It can donate electrons. The assertion is false. The assertion is false, because a reducing agent, it doesn't accept electrons, it lose electrons, because it donate electrons. That's how it reduces other substances. No one is answering. Only one. You is answering. Divyanshu answered. Reason is a substance which helps in oxidation is known as reducing agent. Nope. Reducing agent is a substance which helps in reducing agent is a substance which helps in reducing other substances. Okay, it does not help in oxidation. Yes, it reduces other substances and gets oxidized itself, but it is reducing other substances, not reducing itself. Okay, so it is a substance which helps in reduction, not oxidation. That's why it is called reducing agent. Similarly, oxidizing agent helps in oxidation. Reducing agent helps in reduction. Okay, so that means neither is true. Neither is true. Hold on a second. Actually, both are false. Both are false. Both options are false. Okay, because this is not correct, because a reducing agent is a substance which donate electron. Doesn't accept it, it donate electrons. Okay, and a substance which helps in reduction is called a reducing agent. A substance which helps in reduction is called a reducing agent. Okay, that's why neither of them is correct. Neither of them is correct. Good morning. Ferrous sulfate crystals on heating in a dry boiling tube gives the following reaction. This is the reaction. What is the color change in this reaction? Ferrous sulfate. Ferrous sulfate is green in color. Iron oxide is brown in color. Sulfur dioxide, sulfur trioxide, they have rotten egg-like smell. Now see, what is the color change in the reaction? Color is changing from green to reddish brown or brown. Green to brown. Name the type of reaction. What is the type of reaction? This is a thermal decomposition reaction. This is a thermal decomposition reaction. Next, which gas has a smell of burning sulfur? Which gas has a smell of burning sulfur or rotten egg smell? That is sulfur dioxide and sulfur trioxide. Sulfur dioxide and sulfur trioxide. Both gases have the smell of rotten egg or burning sulfur. What happens where SO2 gas is passed through water? What happens when SO2? When you pass sulfur dioxide gas through water, we get sulfuric acid. We get sulfuric acid. That is the reaction which happens when you pass water through sulfur dioxide. Smell burnt matches. No, that is phosphorus. Matches are made up of phosphorus. They are not made up of sulfur. Rotten egg means it's actually rotten egg. You haven't smelled it. I have smelled it. It's like you have sewer, right? Gutters and everything. The smell comes straight from that only. It's like that smell. Yes, what is your question? Ask me. Yes, so the first color changes from green to brown. Type of reaction is thermal decomposition. The gas is sulfur dioxide, sulfur trioxide, and what happens when sulfur dioxide gas is passed through water, we get sulfuric acid. We get sulfuric acid. Yes, whatever question you have, please just say it. I'll answer it. Next question. While performing experiment in chemistry lab, a student took lead nitrate solution in a test tube. To this solution, he added potassium iodide. So this is lead nitrate. And to lead nitrate, he added potassium iodide. Potassium iodide. Okay. What products will he get? What products? Double displacement. Ohm's law, V equals to IR. Ohm's law, that is Ohm's law, right? V equals to IR. Ask Diti ma'am. Physics question, ask her. Thank you, thank you. Okay, see. Double displacement. This is a double displacement reaction. What is your name? Naveen. This is a double displacement reaction. There is an exchange of ions between the reactants. Exchange of ion. This is a cation, this is an anion. This is a cation, this is an anion. There is an exchange of ions between the reactants and products. Okay. That is a double displacement reaction. So if you have a reactant, two reactants, in these two reactants there will be an exchange of cations and anions. Okay. Now see here also, if you try, lead nitrate combines with potassium iodide, we get lead iodide and potassium nitrate. Lead iodide and potassium nitrate. Now this is yellow colored. Lead iodide is yellow colored and we get a precipitate of lead iodide. We get a precipitate of lead iodide. So this is the reactions. You need to balance it. We need 2 on this side. So we'll add 2 here. This is balanced and we'll add 2 here. Now this is balanced completely. Okay. This is the equation. This is the reaction. And what is this reaction? This is a double displacement reaction. This is a double displacement reaction. And this is the balanced chemical equation, different names given to this reaction. Yes, there are multiple names given to this reaction. Yes, 2 names are there. You can either call it double displacement reaction or you can call it precipitation reaction. You can call it precipitation reaction because there is a precipitate forming. Precipitation reaction. Okay, what is precipitation reaction? Again, when you have a insoluble salt, when reactants are combining, when a displacement reaction is happening, and in a reaction when you have precipitate formation, an insoluble salt is getting formed, that is a precipitation reaction. So the multiple names are double displacement reaction or you can call it precipitation reaction. Next question, what is the color of the precipitate formed? It is yellow colored. Again, if you do not remember, you do not have an idea about the colors, go watch that video. All the chemicals are there whose color is required for your 10th class. Okay. Name the compound precipitated. This is lead iodide. The compound is lead iodide. Okay, the compound is lead iodide. Yes, the color is yellow. Yes, the color is yellow, yet iron corrodes faster in moist air. Aluminum is more reactive than, hold on a second. Aluminum is more reactive than iron. Aluminum is more reactive than iron. Hold on a second. Calling me. Okay, let's see. Yet iron corrodes faster in moist air. Iron corrodes faster in moist air. Actually, for aluminum, we do a technique called anodizing. So, on aluminum itself, we make thick layer of aluminum oxide. We make thick layer of aluminum oxide. And that's how you prevent it from getting corroded. For iron, you do galvanization, but important work. Hold on a second. Where is? Let me just do one thing. My laptop gets stuck. You guys don't want to study or something? See, where is that person? Aluminum is more reactive than iron, that is true. But what happens with aluminum, when aluminum in presence of air forms aluminum oxide. Okay, aluminum oxide. It forms a layer of aluminum oxide and thus prevent it from further oxidation. With the time, obviously, it gets corroded, but it forms a thick layer of aluminum oxide. You know, one technique called anodizing, that is this technique. When you cover aluminum with thick layer of aluminum oxide so that it does not get corroded with time. But iron, for iron, when iron combines with air and moisture, it forms hydrated iron oxide, but it is that rust thing you have seen, right? It is flaky, brown colored flaky thing, right? It weakens it, right? And the iron oxide doesn't strengthen it, but aluminum oxide strengthens the aluminum, right? The aluminum oxide strengthens the aluminum, but for iron, the iron oxide, which is rust, it is flaky and it it corrodes the whole material, okay? That's why it corrodes faster, because iron oxide and aluminum oxide are different. They have different nature because of that. Picture-based questions. Yeah, next question. Gas A, which is the major cause of global warming, combines with hydrogen oxide B in nature in presence of an environmental factor C and a green material to form a 6-carbon organic compound E and a gas F. The gas F is necessary for breathing. I think after reading this question, you know 1-2 things. After reading the question, you guys know 1-2 things. And what are those things? Biology will be on day 4, don't worry. Gas A would be carbon dioxide, yes, because it is the major cause of global warming. So before even starting the question, we know gas A is carbon dioxide. Okay, now what about gas F? Gas F is necessary for breathing. Which gas we breathe? Oxygen. That means gas F is oxygen. Some doubts are clear. Okay. When gas A combines with hydrogen oxide B in nature in presence of an environmental factor C and a green material D. I don't know about you, but I do know a green material D may be chlorophyll. It is talking about photosynthesis, no? They are talking about photosynthesis. So when carbon dioxide combines with water in presence of sunlight and chlorophyll, what do we get? We get glucose plus oxygen gas. Isn't that the whole reaction? Gas A, which is responsible for global warming, combines with hydrogen oxide, this is an oxide of hydrogen, water, in presence of an environmental factor C, in presence of sunlight, right? And a green material D, chlorophyll. That material is chlorophyll and forms a 6-carbon organic compound. This is 6-carbon organic compound called glucose, which is E. This is glucose. Right? And a gas F, which is important for breathing. This is your gas F. I think everything is here. Everything is here, right? Yes. These all are very important questions. You will see some in your exam, okay? So focus on them. What is gas A? Gas A is carbon dioxide, common name of B. Common name of B is water. What do you think of would be C? C is sunlight. What is the material D? D is chlorophyll. Where is it found? It is found in plants. Name the organic compound, plant leaves may. Name the organic compound E. E is glucose. What is the gas F? Name the natural process during which it is released. This process is photosynthesis. This process is photosynthesis and the gas is oxygen. This process is photosynthesis and the gas is oxygen. Okay. See, carbon dioxide is called an acidic oxide because if you combine carbon dioxide in water, we get an acid, carbonic acid. Because we are getting an acid when we combine carbon dioxide in water, this is called an acidic oxide. While when we combine calcium oxide in water, we get calcium hydroxide. We get calcium hydroxide. What is calcium hydroxide? It is a base. Calcium hydroxide is a base. So that's why calcium oxide is basic in nature, while carbon dioxide is acidic in nature. I hope it is clear now. Yes, your answers were correct. And my net is not working. Okay, next question. When a black metal compound XO is heated with a colorless gas Y2, then metal X and another compound Y2 are formed. Metal X is red-brown in color, which does not react with dilute acids at all. Gas Y2 can be prepared by the action of dilute acid or any active metal. The compound Y2O is a liquid at room temperature which can turn anhydrous copper sulfate blue. Tomorrow we'll teach physics. Okay, just tell me the answer. Let's start with black metal compound XO is heated with a colorless gas Y2. Then metal X and another compound Y2O is formed. I don't know about you, but I do know a black metal compound XO, copper oxide. And when I heat it with a colorless gas, hydrogen, I will get copper and H2O. Metal X is red-brown in color. This is metal X. It is red-brown in color, yes, which does not react with dilute acids at all, okay. Gas Y2 can be prepared by the gas Y2. This is gas Y2. Can be prepared by the action of a dilute acid or any active metal. Yes, because when you combine metal with acid, we get salt plus hydrogen gas, right? Salt plus hydrogen gas, okay. Gas Y2 can be prepared. The compound Y2O is a liquid at room temperature which can turn anhydrous copper sulfate blue. Then my dear students, anhydrous copper sulfate, it combines with 5 water or crystallization and we get copper sulfate pentahydrate. Copper sulfate pentahydrate, which is blue in color. Okay. So we have everything. We started with just one. Okay, then we had the idea that we are getting a metal. From a metal oxide, we are getting a metal. Okay, so what do you think of is metal X? It is copper. What could be gas Y2? Gas Y2 is hydrogen. Gas Y2 is hydrogen. What is the compound XO? Is copper oxide. Y2O is water. Write the chemical equation of the reaction which take place on heating XO with Y2, which is copper oxide with hydrogen. Again, same reaction. We will get copper plus water. Now tell me, what is this reaction called? What is this, oxidation or reduction? Is this oxidation or is this reduction? Is it oxidation or reduction? Hydrogen, yes, Y2 is hydrogen. Reduction. Yes, it is reduction. See, copper oxide is getting converted into copper. That means it is reduction. Hydrogen is getting converted into water. Addition of oxygen. This is oxidation. So this is a redox reaction. This is a redox reaction. Clear? Is it clear, everyone? Yes, reduction. This is reduction, not reduction. It is redox reaction. Next question. Or yes. Clear. I have no idea what is ACBSE. Let me see. How many questions are there? 2 more questions are there. Yes, you got this. Let's start. Yep, this was the question. A solid substance which is very hard is used in the construction of many buildings, especially flooring. When substance P is heated strongly, it decomposes to form another solid Q and gas R. Solid Q reacts with water, releases lots of heat to form a substance S. I think we all know it. We are talking about calcium carbonate here. Okay, and when you heat it strongly, this is P. When you heat it strongly, we get calcium oxide and carbon dioxide. This is the gas R and this is the solid Q. After that, solid Q, which is calcium oxide, reacts with water. Quick lime reacts with water to form slaked lime and lots of heat is released. This is exothermic. This is an exothermic reaction. Okay, release of heat to form a substance S. This is the substance S, calcium hydroxide. This is the substance S. When gas R is passed through a clear solution of substance S, gas R is passed through a clear solution of substance S, the same substance T is formed. The substance T is the same chemical composition. So again, if you pass carbon dioxide, we will get calcium carbonate. Okay, this is T equals to the initial substance P. Simple. See, that is how CBSE word plays. They write the question, same reaction. This is the one single, 2 reactions, we know them already, but they word played it so that you get confused. See, this is the application part used in the construction of many buildings, especially flooring. If you did not know that, you will not be able to answer this question, because we know that calcium carbonate flooring sometimes we use for construction and everything, right? Limestone. Is it clear? Okay. Question is done. One more question is left for this chapter. You have ferrous sulfate. If you boil them, what is the color change you will observe? So it is just thermal decomposition of ferrous sulfate. Ferrous sulfate. This is the reaction that happens when you heat ferrous sulfate. Before that, one more reaction is there actually, because ferrous sulfate has 7 water of crystallization. So firstly, if you heat it, it will lose its water of crystallization. And then after that, if you heat it for longer period, prolongedly you heat it, it gets converted into iron oxide, sulfur dioxide and sulfur dioxide. Okay. Next chapter. We are starting our next chapter, acid, bases and salt. Acid, bases and salt. Give me 2 minutes. Yes, it is green color. Yes, because none of you were listening. You all were busy chatting. All were busy chatting. Yes, Fe2O3 is brown, not white. Ready? Start karo. Yes, let's start. Why only you? I want all of my students to listen to me. Okay, let's start. After this chapter, we'll take a break, okay? A 5-minute break we'll take. I need 5-minute break. And please stop talking about all this getting to know thing, because this is not your time. You have your exam coming, right? You should be serious. You should be studying. This is not the time to make joke, to talk to your friends, right? You should focus on your study for this time, only for this 1 month. I think your papers are finishing till 7. Okay? Please don't do it. If you are here for chatting, go to other live. Okay? Do not need to stay here, because some people are here who wants to study. Okay? Yeah. So get serious, you know. You won't be getting second chances. You are getting, but at least you need to pass in this one. Only then you can sit for that second board. I really thought you'll understand, but none of... Yeah, they are here for chatting. That is so bad. You are sitting there right in front of your parents. You are lying to them, straight to their face. Beta, your result will show. Your result will show what were you studying, what were you doing on your phone. Okay, so do not do that mistake. You have time, study now. Okay. Maths didn't go well, English went well. You don't know how, we also don't know how hard or how easy will be your science paper. It'll be competency based, trust me. Competency, we can't predict competency, right? They can ask anything. They can ask anything. I'm not trying to scare you, but I'm trying to warn you. You have time, utilize it in a good way. Utilize it to study. Not for chatting, not for socializing with people, right? Not for making relationships here. That is so bad and pathetic, actually. Good morning, everyone. So yes, I'm starting this chapter. I won't be reading your comments till I get to the question. Please don't chat. If you're here for chatting, just leave this live and you go to the other live for chatting, okay? I see your hard work. I see all my students who are working hard. I am with you. So do not worry. We all are working very hard for you guys. But if you come here and chat, that is not something you should do, actually, because it demotivates us as a teacher also, because we have energy, we want to put effort in you. But here you are chatting, making relationship thing and all. Okay, let's start. Okay, FF Gamer will focus on the indicators. There are 4 indicators you need to know, nothing else. That was your first paper. How can you? It was your first time sitting for boards. When I sat for my boards for the first time, I was scared. And the first paper did not go according to my expectations, because I was expecting something else. And the paper was a little harder because I never sat in a board, right? So do not think about it much, first of all. You have other papers left. Sit down and, you know, prepare for those papers. After that, think about that, okay? And yes, it happens. The first paper was hard because it was your first time giving a board exam, properly giving a board exam. For your 12th board, you won't see this, you won't feel this difficulty, because you have already sat down for your 10th boards. Yeah, that's why they say boards are different. You see in boards, we'll see your marks in boards, right? But it's okay. You have other papers to cover it up, right? You have other papers, so cover it up in the other papers, right? Make it up for the for maths in the other subjects, okay? Yes, all factor indicators. You have 2 all factor indicators. We'll discuss them. Imposter, I believe, yes, the paper was really hard. The checking will be a little lenient, okay? It will be lenient if the paper was really hard. That's how it goes for each exam. If the paper is difficult, checking is lenient. If the paper is easy, the checking will be hard, okay? So it's a vice versa phenomena. Yeah, as compared to the previous year exam, but this year they introduced competency-based question. If you are not mentally prepared for competency-based question, if you're expecting that, no, I'll go and 50% will be your previous year question paper questions, it is not going to happen, trust me. Previous year questions will give you an idea. They will give you a blueprint of how, what kind of questions you will get in your exam, but they are not the exact questions that are going to come in your exam. CBSE especially change the guidelines, no? 50% competency-based questions will be there. So be prepared. 50% will be competency-based. Have that mentality. You can't blame the system all the time. Paper would be from moderate to difficult level, I believe. I've seen the paper. But yes, you need to manage your time also, because 3 hours you are given only, right? You have to complete your paper in 3 hours. If you do not complete it in 3 hours, even if you know all the answer, it doesn't matter. Okay, any other doubt you have? Okay, so let's start seriously. Okay, again, one last time I'm saying, if you are here for chatting, leave the live. I don't want you here, okay? Here only the students who want to study, who are actually listening, who are here to solve questions, who are here to complete their chemistry. Please be here. I am there for you. But if you're here for chatting and making, socializing and everything, this is not the place for you, okay? Okay, acid, bases and salts. So we'll talk about acids and bases first. What are acids? Acids in general, physically, if we are talking about physical characteristics, acids are sour in taste. They turn blue litmus red. They give hydrogen ions. They give hydrogen ions in aqueous solution. So when you dissolve acid in water, we get hydrogen ions, right? But these hydrogen ions also combine with water and we get H3O positive, hydronium ions. These are hydronium ions. So basically there are some physical characteristics and then there are some chemical characteristics. These are the physical characteristics, that acids are sour in taste, they turn blue litmus red, they give hydrogen ions when dissolved in aqueous solution, they conduct electricity. Why do they conduct electricity? Always remember, conduction of electricity is done because of two things, ions and electrons. Either of these are there or both of these are there, so electricity conduction will happen. Okay? So here we have ions, we have hydrogen ions, and due to these hydrogen ions, they will conduct electricity. And if you are talking about acids, what is the pH range? pH is less than 7. There are two types of acids, strong acid, weak acid. Strong acids are those acids which dissociate completely in aqueous solution. If you dissolve an acid in aqueous solution and it dissociates completely as H positive and its respective anion, for example, for HCl, it dissociates completely as H positive and Cl negative. Let's say if you have 100 molecule of, if, my dear students, you have 100 molecule of HCl, hydrochloric acid, it is a very strong acid. So if you dissolve it in water, of these 100 will be present as H positive and 100 will be present as Cl negative. Complete dissociation, 100% dissociated, right? So as soon as you dissolve them in water, they will be present as ions H positive and Cl negative, right? Then what about weak acids? Weak acids are those acids which ionize partially, which dissociate partially. Partially means they will be dissociated around 4 or 5%, okay? So if you have 100 molecules of, let's say, CH3COH, acetic acid. If you have 100 molecules of acetic acid, out of these 100, only 5 will be present as this. Only 5 will be present as ions, acetate ion and hydrogen ion. Acetate ion and hydrogen ion, only 5%. Rest 95% will be there as acetic acid only. Rest 95% will be there as acetic acid only. 95%. Okay, this is the physical characteristic of acids. Now what about bases? In bases, we have again, bases are bitter in taste, right? they turn red litmus blue. They give hydroxide ion. This is hydroxide, OH negative ion. In aqueous solution, we have water soluble bases. So see, bases may or may not be water soluble. Bases may or may not be water soluble. But water soluble bases are called alkalis. Okay, you have two categories, right? You have bases, they can be water soluble and can be water insoluble. Okay, if a base is water soluble, it is called alkali. It is called alkali. And if the base is water insoluble, then it is called base only. Okay, so water soluble bases are called alkalis. What are the example of alkalis? Potassium hydroxide, sodium hydroxide, right? These all are water soluble bases. They are soluble in water. Now, bases have a pH greater than 7. Again, there are two types of bases: strong bases, weak bases. Strong bases are those bases which dissociate completely in aqueous solution. So as soon as you dissolve them in aqueous solution, they will dissociate as Na positive, OH negative, K positive or OH negative. Weak bases are those bases which dissociate partially A or incompletely. Again, partially means if 100 molecules are there, only 4 or 5 molecules will dissociate as ions, rest will be there as whole. So if you have 100 molecules of ammonium hydroxide, only 5 molecule will be dissociated as NH4 positive and OH negative, right? Rest 95% will be there as whole ammonium hydroxide only. That is a weak base. Okay. Now, chemical properties. Let's discuss alkalis first. What are alkalis? They are bases which are water soluble. Water soluble bases. They are soapy to touch, bitter. Examples: ammonium hydroxide. Potassium hydroxide, sodium hydroxide. Properties are they are soft and they have very low density. They have very low density, right? They have low melting and boiling point. They give a characteristic color flame. They react with halogens. They can be stored in mineral oil solutions. That's why you store. The question comes. Why we store potassium or sodium in kerosene oil, right? Why not kept in open air? Because they are very, very reactive. They react vigorously with oxygen, okay, and form sodium hydroxide, sodium oxide or potassium oxide, okay, and lots of energy is released. It's kind of an explosive reaction. Violently they react, na. So you will get lots of heat energy will release. Explosion like like a bomb explosion will happen. Okay, so that's why you do not keep it in open air, because they react vigorously with oxygen. And that's why you keep it in mineral oil, which is in kerosene oil solution. In kerosene oil solution. That is alkali. Okay. Next is chemical properties of acids. What chemical reactions are shown by acids? So acids react with metals and produce salt and hydrogen gas. Which gas? Salt and hydrogen gas. Okay, this is one reaction. We have acid HCl and metal zinc. It reacts with metal and it forms salt, zinc chloride and hydrogen. Similarly, we did this, right? Iron combines with hydrochloric acid. Metal combines with acid and we get a salt and hydrogen gas is released. How do metals react? Then there is one more reaction. Acids react with metal carbonates, metal hydrogen carbonates, or you can metal carbonates or metal bicarbonates. Acids also react with those. But in this case, the product is different. You are getting salt, that is correct. But alongside salt, you will get carbon dioxide and water. Alongside salt, you will get carbon dioxide and water. So remember, when acid react with metals, hydrogen gas is evolved. When acid react with metal carbonate and metal bicarbonate, there is carbon there, right? So carbon dioxide gas will be released. Okay, just remember it using the name, because sometimes you forget what product you have to make. Then how do acids react with metal oxides? Now, my dear students, I have told you, metal oxides are basic in nature. Why they are basic in nature? Because when you combine a metal oxide, let's say this is a metal oxide, and if you combine a metal oxide in water, you get a base. You get a base, right? Base. That's why metal oxides are basic in nature. And when acids and bases react, we get salt and water, right? When acid and bases react, we get salt and water. So when acid react with metal oxide, we will get a salt and water. Calcium oxide, right? We get calcium chloride and water. Clear? Next is reaction of bases. chemical reaction of bases. What kind of reactions are shown by bases? Let's recap the acid one. They react with metal, form hydrogen gas. React with metal carbonates, metal bicarbonates, give carbon dioxide gas. React with metal oxide, give salt and water. Okay, three reactions we have studied. Next is a reaction of bases. Bases react with metals. Some bases react with metal. Some metals react with bases. Okay, so you have three metals actually: zinc, aluminum, and lead. These three metals are amphoteric in nature. That means they react with both acids and bases. Okay, because my dear students, bases and metals have the same nature. Both wants to donate electrons. Bases want to donate electrons, and metals also want to donate electrons, right? They are electropositive, right? So if both wants to donate electrons, then how will a bond form between them? A wants to donate electrons, B wants to donate electrons, no bond will form. What will happen? No reaction will happen. So what is the requirement? A should be able to donate electron, B should be able to accept those electrons, right? That's how a handshake happened, right? So the same thing happens here. Only these three metals react with bases: zinc, aluminum, and lead. Why? Because these are amphoteric in nature. These are amphoteric in nature. Rest metals do not react with bases. They will react with acids, but they will not react with bases. Okay, so when base react with a metal, we get salt and hydrogen gas. Clear? This salt is important. This is sodium zincate. This is sodium aluminate. Okay. Now, how do bases react with non-metallic oxide? Again, non-metallic oxide. We discussed, right? Carbon dioxide. It is a non-metallic oxide. And non-metallic oxides are acidic in nature. Why? Because if you combine non-metallic oxide in water, you get an acid. You get an acid. Right? That's why non-metallic oxides are acidic in nature. Now, base and acid, again, we get salt and water. If acid and base react, it is a neutralization reaction. We get salt and water. Next, reaction with acids, when acids and bases combine, that is a neutralization reaction, right? We get salt and water. Simple. Clear? So bases undergoes three reactions. Reaction with metals, only three metals bases react with: zinc, aluminum, lead. Why? Because these three metals are amphoteric in nature. That means they will react with both acids and bases. What are the products? We get salt and hydrogen gas. Salt and hydrogen gas. Next, metals react with non-metallic oxide. Now, non-metallic oxides are acidic in nature, and acids and bases, when they react, we get salt and water. Right? Next, bases react with acid. When acids and bases react, we get a salt and water. Again, this is a neutralization reaction. Okay. Next, the pH scale. So there is a pH scale which starts from 0 and end at 14. How do you calculate the pH value? That is, pH is equal to, this formula is not coming in your exam, I'm just telling you, it is negative logarithm of H positive. That means whatever the hydrogen ion concentration is, if you take the negative logarithm of that, you will get the pH value. Okay. Now see, you have from 0 to 14. At 7 you have neutral, which is water, and these all are acidic. Below 7 is acidic, and above 7 is basic. You need to remember the color. The color is from reddish, red to yellowish orange, red, orange, yellow, right? These are the color for acids. For bases, the color is green, purple, blue, green, blue, and purple, right? Green, purple, blue, violet, right? Any color you can say, purple, violet, same. So this is the color. This is the color you need to memorize. Actually, you need to have an idea what color. If bases are there, the color will be on this side, green, blue, violet, and if acids are there, the color will be on this side, yellow, orange, red, right? Okay, because it will come handy. Indicators, yes, these are the indicators. 4, I told you, only these indicators are there. So if you have litmus paper, so when you put litmus paper in acid, what will happen in acid? Blue litmus will turn red. Blue litmus will turn red. Take a screenshot of this. This is all you need for indicators. I believe the color is clear. Yes. With bases, my dear students, with bases, the color changes from red to blue. The color changes from red to blue. And for acids, the color changes from blue to red. This is very easy. Everyone remembers it. These one, it gets a little tougher. Phenolphthalein. So phenolphthalein is a pink color indicator. Okay, if you don't know, but it is a pink color indicator. No, it's not pink color. Phenolphthalein, it's colorless, yeah. So when you add phenolphthalein in acidic medium, it will remain colorless only, okay. If you add drops of phenolphthalein in acidic medium, that is pH less than 7, it will remain colorless. But if you add phenolphthalein in basic medium, that is pH greater than 7, what will happen? The color changes to pink. The color changes to pink. So colorless to pink for basic solution, for acidic colorless. So you can write here, it is colorless for acidic solution and the color changes to pink for basic solutions. For basic, in basic medium, phenolphthalein is pink colored, okay. For this, how I memorized it, because I did experiments in lab, that's how I remember it, because when I put the dropper and when the medium changed to basic medium, the color was pink, okay. That's how I memorized it. We did lots of titrations, but for you this is the only chart you need. For methyl orange, there's one more indicator, methyl orange. So when you add methyl orange to acid, the color is red. Methyl orange, it turns red colored, and when you add in basic medium, it turns yellow colored, okay. Methyl orange, the name is methyl orange, okay. Just think about it. In acid, the color gets darkened, right? The colors are red, yellow, orange. So in acidic medium, the color will be red. In basic medium, the color lighten up, right? A little lighter than red will be yellow, right? So in basic medium, methyl orange will give yellow color, right? Then you have olfactory indicators. You have onion and vanilla essence, vanilla extract or vanilla essence, whatever you call it. So for olfactory indicators, my dear students, with in acidic medium, they will retain their odor. Onion has a characteristic smell, right? Similarly, vanilla extract also has a characteristic smell. They will retain their odor, they will retain their smell in acidic medium, no change in their smell. But when you add them in basic medium, they will lose their odor. There will be no smell for these, for olfactory indicators. Firstly, olfactory indicators are smell based indicators, right? You are not seeing any color change. So for visually impaired students, normally we use olfactory indicators, okay, because they can smell it and they can tell if it's an acid or a base. So if you put onion, in acidic medium, it will still retain its odor, right? You have heard of that vinegar onion, right? That is served in restaurants and all. Still it has that onion taste and smell, right? But if you put it in basic medium, they will lose its odor. There will be no smell to onion, okay? You can try it at home also, okay? Next is salts. What are salts? So salts are the product of neutralization reaction between acids and bases. So when you have neutralization, when you have acid and base, acid and bases combine and we get salt and water. Depending on the strength of acid and base, we have 3 types of salts: acidic salt, basic salt and neutral salt, okay. So if we have a strong acid combining with a strong base, we get a neutral salt. If a strong acid combines with a weak base, then we will get an acidic salt. And if a weak acid combines with a weak base, a weak acid combines with a strong base, we will get a basic salt. They can be acidic, basic, neutral. Salts conduct electricity. Why? Because, okay, one more thing, salt conduct electricity in molten state. That means if you melt them, they will conduct electricity. Why? Because in molten state, they will have ions. Okay? And in solid state, they do not have any ions, okay? Why? Because they are crystalline, they are solid, right? They are not present as Na positive and Cl negative. They are present as NaCl only. We need Na positive and Cl negative for electricity conduction. That's why we either melt them or we make an aqueous solution of it. They have high melting and boiling point, and they are insoluble in organic solvents, because salts are ionic compounds. They are soluble in polar solvents. You have polar solvents, non-polar solvents. Polar solvents are those solvents which has poles. For example, you have H2O, right? In H2O, you have HOH. It has positive, it has negative. These are poles, positive and negative charges, okay? There is a charge separation in the compound, that is poles. Okay, if you have these poles are there, if poles are there in any compound, you call them polar compound, right? But non-polar compound are those compounds which do not have any charge. For example, benzene. For example, benzene, there is no charge separation between carbon and hydrogen because they have same electronegativity. So that's why they are called non-polar solvents. Now, since this has ions, and salt also has ions. Salt has ions and this also has ions. So that's why they dissolve in ionic compounds, dissolve in polar solvents, because like dissolves like. That is the phenomena that has been used from your 9th standard, I think. Like dissolves like. So polar solvents, ionic compounds dissolve in polar solvents, not in non-polar solvents. Okay. Next, common salt. There are some salts actually that we need to discuss in this salt section. First is common salt, which is sodium chloride. How do you synthesize sodium chloride? One reaction is neutralization. Sodium hydroxide combined with hydrochloric acid, it's a salt, acid, strong base, we get sodium chloride. But you can't consume this sodium chloride because again, strong acid, HCl is there, and strong base is there. Both are corrosive in nature. We can't consume them. So how do we synthesize it? You have oceans, right? From oceans you get deposition of salt. There are salt deposition oceans, right? And you evaporate the water and that's how you get the salt. Okay, large deposition of salts are there in these sea beds, right? And there you people extract the salt from there, they evaporate the water, and that's how we get pure salt. Obviously purification is done, then you add iodine and everything, right? How do you it is used as a food preservative, and it is a raw material in manufacturing of sodium carbonate, sodium hydrogen carbonate. Okay, remember it. It is a raw material, right? One more thing, what is brine? Brine is an aqueous solution of sodium chloride. Brine is an aqueous solution of sodium chloride. Okay, remember it. Brine is an aqueous solution of sodium chloride. Caustic soda. Next salt is caustic soda. So caustic soda is sodium hydroxide. Caustic soda is sodium hydroxide. How do you synthesize it? That is by chlor-alkali process. Remember this process, chlor-alkali process. What is chlor-alkali process actually? When electricity is passed through an aqueous solution of sodium chloride, it decomposes to form sodium hydroxide or caustic soda. It decomposes to form sodium hydroxide or caustic soda. Okay. Alongside that, we have chlorine gas and hydrogen gas is also produced. Chlorine gas is produced at anode and hydrogen gas is produced at cathode. Clear? Also, this sodium hydroxide is also produced near cathode only. Okay. That is chlor-alkali process. When electricity is passed through an aqueous solution of sodium chloride, it decomposes to form sodium hydroxide, and during electrolysis, chlorine gas and hydrogen gas is also produced. Chlorine gas is produced at the anode and hydrogen gas is produced at the cathode. Okay. This is the reaction, and obviously where do you use sodium hydroxide? For making soaps, for making detergents, right? It's a base, so you use it for basic material. Okay. Next is bleaching powder. What is bleaching powder? This is bleaching powder, calcium oxychloride. Calcium oxychloride is bleaching powder. How do you synthesize bleaching powder? You remember the last reaction, chlor-alkali process. Okay, why do we call it chlor-alkali? Because sodium hydroxide is an alkali and we are getting chlorine gas also. So chlor-alkali, that's how it got its name. So if you are confused anytime, just remember chlor-alkali means chlorine gas is there and alkali means sodium hydroxide will be there, right? And water is already there. Okay. Then how do you synthesize calcium oxychloride, which is your bleaching powder? The bleaching powder is prepared by action of chlorine. You have calcium hydroxide, right? You have calcium hydroxide, or you can say slaked lime. If you pass chlorine gas through dry slaked lime, we get calcium oxychloride, which is bleaching powder, right? Now, which is the bleaching agent in bleaching powder? This is not the bleaching agent, right? This is not the bleaching agent. This is just a form of storing. This is just a form of storing your bleaching agent. The bleaching agent is chlorine gas. the bleaching agent is chlorine gas, right? You bleach your hair, you bleach your clothes, right? That is the bleaching powder. Now how do you get this bleaching agent? You have the bleaching powder, and if you actually add any dilute acid to it, you have a bleaching powder, add little dilute acid to it, okay, and that's how you get your bleaching agent, okay. So the medium is acidic, you add little acid to bleaching powder, and that's how you get your bleaching agent. This will work, this will do the bleaching. It is used to disinfect, as a disinfectant it is used, and also as an oxidizing agent. Next salt is baking soda. What is baking soda? Sodium hydrogen carbonate. This is baking soda, right? Sodium hydrogen carbonate. How do you prepare sodium hydrogen carbonate? So you have again brine. This is brine, aqueous solution of sodium chloride, and you put ammonia and carbon dioxide gas, okay. You put ammonia to this solution, to this brine solution, and pass carbon dioxide gas through it, and that's how you get sodium hydrogen carbonate, which is baking soda. It is used for baking purposes and also in soda acid fire extinguisher. So you take baking soda and you have a strong acid, right? And when you know baking soda and strong acid reacts, we get lots of carbon dioxide gas. This is used as, this is the extinguisher, right? This will help put off the fire. So that's why we have this soda acid extinguisher, where you have baking soda and sulfuric acid, okay. This is the reaction you get, that's how you get your baking soda. Now before moving to baking other salt, we have baking powder. What is baking powder? Is it different than baking soda? What is baking powder? Is it different than baking soda? Okay. Okay, so baking powder is different than baking soda. What is baking powder? It is a mixture of baking soda and any edible acid. I'm using tartaric acid, but any edible acid, not a strong acid, any edible acid. So baking powder is a mixture of baking soda and any edible acid. Now you see, my dear students, baking soda is NaHCO3, it is basic. So when you add baking soda, so you add it for pakoras and something, it has that little bitter taste, it has that little bitter aftertaste. To remove that taste, you do not want that taste in baking, so that's why we use baking powder. What is baking powder? It is a mixture of baking soda and tartaric acid, any edible acid, okay. It has sweet smell, it has this sweet taste, you know, and it obviously fluffs out. Baking powder, the use of baking powder is purpose is to fluff out stuff, right? You want a fluffy cake, you want fluffy muffins, cupcakes, okay. Next is washing soda. Washing soda is produced by a process called Solvay process, that is very important. So the Solvay process is simple. Actually, it has multiple steps. I'll go to the back one. The Solvay process starts from here actually, okay. So when you get baking soda, after getting baking soda, we heat the baking soda. We heat the baking soda and we get sodium carbonate. We get sodium carbonate, okay. If this sodium carbonate add 10 water of crystallization, and then we will get washing soda. This whole process, this is reaction 1, this is reaction 2, and this is reaction 3. All these 3 reactions comes under Solvay process, okay. It is the process for synthesis of washing soda. Okay, it is the process for synthesis of washing soda. That's how you synthesize it. You take a brine, you add ammonia, pass carbon dioxide through it, you get baking soda. Heat the baking soda, you get sodium carbonate. Add 10 water of crystallization to sodium carbonate, and that's how you get washing soda. Okay, that is the reaction. Next is plaster of Paris. It is synthesized by the salt calcium sulfate hemihydrate, which is gypsum. Okay, how do you synthesize it? So if you have gypsum and you heat it around 373 Kelvin or 100 degrees Celsius. If you heat gypsum around 100 degrees Celsius, you will get calcium sulfate dot half H2O, which is plaster of Paris. Right? And it will lose 3.5 water of crystallization, right? Plaster of Paris is used for curing fractured bonds, right? For making toys, material for decoration and everything, for making surfaces smooth. That is plaster of Paris. You synthesize it by using gypsum. You heat it up to 100 degrees Celsius, and if you heat it up to 100 degrees Celsius, we will get plaster of Paris, which is calcium sulfate dot half H2O. I think, yep, we are done. We have to start the questions now. Okay. Which of the following statement is not correct? You have to identify the not correct statement. Now show me who are there. Just who is listening? Who was listening? Still people are talking, but at least is anyone there who was listening? I'm still talking. Which of the following statement is not correct? Good, Yash. Dhoni is also listening. Okay. So, which of the following statement is not correct? You have to identify the incorrect statement. The first is metal carbonates react with acids to give salt, water and carbon dioxide. Incorrect statement. This is a correct statement. Yes, metal carbonates react with acid to give salt, water and carbon dioxide. All metal oxides react with water to give salt and acid. Yes, this is not correct, because metal oxides combine with water and they give what? They give base. Let's do an example. This is a metal oxide, and when metal oxide combines with water, we get base. This is incorrect. Some metals react with acids to give salt and hydrogen. Yes, that is correct. Metals react with acids to give salt and hydrogen. Some non-metal oxides react with water to form an acid. Yes, non-metal oxide, if you combine them in water, they form acid. That's why they are called acidic oxides. So this is also correct. Hence, the correct answer is option. We are asked the incorrect answer. We are asked which of the following is incorrect. So the correct answer is option B. Next question. Which of the following phenomena occur when a small amount of acid is added to water? When you add little acid to water, right? When you have water, you add acid to it. What is this process? This is called dilution. This is called dilution, right? This process is called dilution. Ionization is different. Neutralization, acid and base. Respiration is absolutely different. Ionization means ions are getting formed, but here if you add small amount of acid to water, that is not ionization, that is dilution, right? You are diluting that acid dropwise. Next question. Assertion says all factory indicators are those whose color changes in acidic and basic medium. That is incorrect, because all factory indicators are smell based indicators. They change smell when they are exposed to acids and bases. So that is incorrect. Reason, they react with acidic and basic solutions. So the reason being they react with acidic basic solution, that is correct. That is correct. They react. Assertion is true, but the reason is false. Both assertion and reason are false. We don't have the option. Both assertion and reason are false. Yes, they do not react. They react, they do not react. They're just showing the Hi Ria. Okay, so here the assertion is incorrect and when you're talking about indicators in acidic medium, they changes color. So they actually don't they changes color because yeah, they react with acidic and basic solution. So the answer is assertion is true, assertion is false, but the reason is true. But since we are not giving the option, I'll make it. Yes, ask your doubt. Yes, Shubham, ask your doubt. Whatever doubt you have, please ask. Plaster of Paris is obtained on heating gypsum at 373. On heating gypsum at 373, it loses water molecules. Yes. Yeah, I'm not CBSE, Nikhil. If I'm CBSE, still I wouldn't leak it. Yes, any doubt you have, please tell me. See, plaster of Paris is obtained on heating gypsum at 373 Kelvin. This is gypsum, right? And if you heat gypsum at around 100 degrees Celsius or 373 Kelvin, you will get calcium sulfate dot half H2O. It loses 3.5 water molecule. It loses 3.5 water molecule, right? So the assertion is true, and reason because on heating gypsum, the reason was because on heating gypsum at 373 Kelvin, it loses water molecule. Yes, that is correct. So that means the assertion reason is correct, and reason is the correct explanation of assertion. Next question. Again, NaCO3 is, okay, let's start with the first one. NaCO3 is baking soda. NaOH is alkaline. Calcium hydroxide has bitter taste, and KHSO4 is acidic salt. Is it there? Is it there? Is it there? Why the options are not matching? NaCO3 is baking soda. NaOH is alkaline. KHSO4 is acidic salt. Yes. Not acidic exactly. HSO4. Yeah, it is acidic. CHO twice, bitter taste. I think this is not the correct options given here. Nope. We'll try again. This is the correct answer. NaCO3 is baking soda, NaOH is alkaline, and KHSO4 is, it's actually the combination of, it's a neutral salt, not acidic. It's a neutral salt. And calcium hydroxide has a bitter taste, and calcium hydroxide has a bitter taste. Like when we complete all the chapters, the live will end. Don't worry. If I'm spending my Sunday with you, you mean a lot actually. You should study. You should not be asking about the ending time, you know. A doubt, where is the doubt person? Yes, yeah, doubt. Ask the doubt now. Next question, assertion says hydrogen gas is not evolved when zinc reacts with nitric acid. When zinc reacts with nitric acid, okay, nitric acid oxidizes the hydrogen gas, produced water and itself gets reduced. Okay, so see, when zinc reacts with nitric acid, my dear students, when zinc reacts with nitric acid, yes, no hydrogen gas is evolved. Why? Because we get water here and zinc nitrate. The thing is, nitric acid is a very strong oxidizing agent, so it will convert the hydrogen to water molecule straight away. It will convert the hydrogen to water molecule because it is a very strong oxidizing agent, okay. So no hydrogen gas is not evolved. Why? For only two metals it is evolved. It is magnesium and manganese. For only magnesium and manganese, hydrogen gas is evolved when treated with nitric acid. Unless if any other metal is there and you are treating it with nitric acid, no hydrogen gas will be evolved. Okay, no hydrogen gas will be evolved. So that means the assertion is true. What about the reason? Let's add a because. Let's add a because and try to answer the reason. Nitric acid oxidizes the hydrogen gas produced to water and itself get reduced. Yes, it is a very strong oxidizing agent. That means it oxidizes others and reduces itself. So it gets reduced. It gets reduced, and the hydrogen gas that is produced, it is oxidized to water. Hydrogen gas is oxidized to water. Okay, so that means assertion is true and reason is also true, and reason is the correct explanation of assertion. Next question. Assertion says it is advised that while diluting an acid, one should add water to acid, not acid to water, keeping the solution continuously stirred. Because, add a because. Why? Because the assertion is true. We know that assertion is true. Because the process of dissolving an acid into water is highly exothermic. Correct. This is also correct. So the correct answer is option A. Both assertion and reason are true, and reason is the correct explanation of assertion. Next question. Sodium carbonate is a basic salt because it is a salt of. What is sodium carbonate? This is sodium carbonate. It is a basic salt. Why? Because it is a salt of a strong base with a weak acid. Strong base with a weak acid. Strong base with a weak acid. Correct? The correct answer is option D. Next question. HCl produces hydronium ions and chloride ions in aqueous solution because in presence of water, base give H positive ions. Firstly, the reason is false because base gives OH negative ions, right? And the assertion is true. And the assertion is true because when you dissolve an acid in water, it gives hydronium ions and chloride ions. Obviously, it dissociates completely as it is a strong acid. It dissociates as H positive and Cl negative. This H positive combines with water and we get H3O positive, right? This is the reaction. H positive combines with water and we get H3O positive. Clear? So the correct answer is assertion is true but the reason is false, which is option C. Next question. Assertion says if the pH inside the mouth decreases below 5.5, the decay of tooth enamel begins. That is correct, my dear students, because if the pH of our mouth goes below 5.5, our tooth enamel will start to corrode. Okay, because. Let's add the because and then try to figure it out. The bacteria present in mouth degrades the sugar and leftover food particles and produce acids that remain in the mouth after eating. That is correct. That is the reason. That's why we, firstly, my dear students, the pH of enamel is basic. That's why you brush with a basic toothpaste every day to maintain the enamel safe, right? To maintain the structure of enamel so that your teeth do not get corroded. Okay, but if the pH of your mouth goes below that temperature pH, which is 5.5, what will happen? The medium turns acidic, and in acidic medium, enamel will corrode. So do not do that mistake. Always brush your teeth twice every day. Okay. So yes, both assertion, reason are true, and reason is the correct explanation of assertion, right? Why? Because we added a because and then we said the reason, and it made total sense. Next question. While performing an experiment in chemistry lab, again, I think this question is getting repeated. We are going to skip it. pH of ammonium chloride solution is in acidic range. pH of ammonium chloride. This is ammonium chloride. Okay, it is in acidic range because, let's add a because. Solution of a salt of weak base and strong acid. Ammonium chloride is a salt of ammonia and HCl. Ammonia is a weak base. This is a weak base, while HCl is a strong acid. Yes, because it is a solution of weak base and strong acid. That's why the pH comes in the acidic range, because it is an acidic salt. This is an acidic salt. Clear? So that means the assertion is and reason both are true, and reason is the correct explanation of assertion. Next question. Baking soda does not create acidity in the stomach. Baking soda does not create acidity in the stomach. Yes. Why? Because baking soda is basic in nature. Why? Because baking soda is basic in nature. Because baking soda is not alkaline. That is incorrect. Baking soda is alkaline. Baking soda is basic in nature. It is alkaline. So reason is incorrect, but assertion is true. Assertion is true, but reason is false. Assertion is true, but reason is false. Next question. A milkman adds very small amount of baking soda in fresh milk. Okay. Why does it shift the pH of fresh milk from 6 to slightly alkaline? The thing is, when you have milk has a slightly alkaline pH. Okay. Nope. Milk has a slightly basic pH. Acidic pH. So milk has a slightly acidic pH. So when you shift the pH to basic, slightly alkaline, right? What are you doing? You are trying to prevent it from getting bad. Okay, milk in acidic medium, milk go bad very easily, right? Have you seen it? If you leave your milk in open air for some time, you know, it gets this sour taste and we say the milk has gone bad. Now we will make paneer out of it, right? You have heard of it, right? In your homes. So that's what happens. If the pH gets acidic, the bacteria will work on it and the milk will get bad actually. Okay, so that's why to keep the milk to prevent it from going bad, the milkman adds a base actually, slight amount of baking soda. Now since when you are doing curd formation, curd is acid, right? Curd has lactic acid. So acid is getting formed. That means pH is going to get, you have to decrease the pH. Now you have increased the pH to alkaline, which is greater than 7. Little greater than 7, you have increased it. But now you want the pH to be less than 7 because you want curd, because you want to make curd, and curd has lactic acid. So that means you'll have to come to this pH around it has like 3, 4. No, actually it is 4 to 5. You have to come near this pH, and for coming to this pH it will take a long time. It will take a long time. So he added baking soda. Why? Because he wanted to prevent the milk from going bad. And now as he increased the pH, what will happen? It will take longer time to make curd, and that's why, because the curd has a acidic pH, and you'll have to come down from this pH to this one. Okay. Hello everyone. Next question. Study the table related to the color change with indicator and answer the questions given below. So in solution P, color change with phenolphthalein indicator is pink. That means it is basic. And color change with methyl orange is yellow, then again confirms it's a base. Q, it is colorless with phenolphthalein. That means an acid. Here also it is orange. That means it is an acid. R is also colorless, which means an acid, and this also means an acid. Now in between these orange and red, you should remember it that red is a darker color, right? So that means this is a strong acid, and this is slightly weak. This is slightly weak. So name the solution which is acidic. Solution Q and R are acidic. Q is acidic and R is also acidic. Arrange the given solution in increasing order of their pH value. Increasing order you need to do, right? Increasing means 1, 2, 3, 4, 5, 7. That means you are going from least acidic to basic. Least acidic to basic. So that will be from R, then Q, then P, right? What is the name of the solution P and Q? Name of the solution P and Q. P is a base, and Q is an acid. Clear? Next question. Let me see how many questions we have left. We are almost there. Okay, a metal carbonate on heating with an acid gives a gas which when passed through a solution Y gives the carbonate back. On the other hand, a gas G is obtained at anode during electrolysis of brine and is passed on dry Y. It gives a compound Z used for disinfecting drinking water. I don't know about you, but when I read this question, I have something clear that, okay, let's start from here. When you pass this gas G, a gas G is obtained at anode during electrolysis of brine. When we did electrolysis of brine, we get sodium hydroxide, caustic soda, and also what else did we get? We get chlorine gas at anode. We get chlorine gas at anode, and when we pass that chlorine gas on dry Y, which is calcium hydroxide, we will get calcium oxychloride. This is Z, this is Y. Okay, now if this is Y, when metal carbonate X on heating with an acid gives a gas which when passed through a solution Y gives the carbonate back. Metal carbonate is calcium carbonate on heating with an acid calcium chloride, water, carbon dioxide. Okay, gives the carbonate back, passed through a solution of Y. Yes. So this is the reaction, this is X. Okay. This is Y. This is Y. Let me write it. X is CaCO3. Y is calcium hydroxide. And Z is calcium oxychloride or bleaching. This is the reaction. So I identified using this anode thing because I know when I do electrolysis of brine, I get sodium hydroxide, chlorine gas and hydrogen gas. Okay, hydrogen gas at cathode and chlorine gas at anode. And when I pass chlorine gas through a dry Y, it gives a compound Z which is used for disinfecting drinking water. That means I'm talking about bleaching powder. And I know this is the reaction of bleaching powder. So that means this is Y and this will be Z. And the question was, when X on heating with an acid, when you heat X with an acid, we get a salt, okay, and a gas, which when a gas which is carbon dioxide, and if you pass carbon dioxide through this calcium hydroxide, that is Y. If you pass carbon dioxide through Y, you will get the carbonate back. So if you pass carbon dioxide through calcium hydroxide, you will get calcium carbonate, which means we will get our carbonate back. We will get our carbonate back. Next question. The solution, two solutions M and N give red and blue color respectively with a universal indicator. So M gives red color and N gives blue color. That means this is a base and this is an acid. Okay, the question is, in which solution will the hydrogen ion concentration will be more? Justify your answer. We know hydrogen ion concentration will be more for an acidic solution, so that means it will be more for M. If both M and N solutions are mixed together, the resultant mixture tested with a universal indicator return green. So if M and N solutions are mixed and the resultant mixture when tested against a universal indicator, it is green. So my dear students, green means the solution, the salt is basic. The salt that is formed is basic, right? That means you have a weak acid if you have a weak acid and you combine it with a strong base, you will get a basic salt plus water. this is a basic salt because the base is strong. It will be a basic salt, and it will turn it will turn green. It will give it will turn red litmus blue, right? The more I told you, you remember the color right in the beginning. Green, blue, purple means base. Red, orange, yellow color means acid, right? So this will give green color. Why? Because it is a strong, it has a strong base and weak acid, right? It is a basic salt. Now, my dear students, too much focused you are, but if in your 11th and 12th you want to pursue JEE, NEET, KCT, we have our Diksha Vedantu offline centers. You go check them out, okay? These are our results from this year for JEE main. These all are our toppers, okay? You can be there too, my dear students, if you study, and yes, join our offline centers. They are very good faculty and good infrastructure. Do check them out once, okay? Yes. Now, before it, let me discuss something. Let's have a 10-minute break. I'll be back in 10 minutes. Okay. Till then, okay, see you after 10 minutes. Hello, my dear class 10 students. How was your 10 minutes break, huh? Ready now? Are you all ready now? Let me see. Okay. Yes, let's start. Hello everyone. Hi, imposter. Hello, Ansh. Okay, so let's start. Let's not waste any time because we have still two chapters left. These are very important. Okay, so let's focus on these. Okay, hello everyone. Okay, let's start metals and non-metals. In metals and non-metals, we'll start with metals. What are the physical properties of metals? Metals have luster, they're hard, they're malleable, they're ductile, they're good conductor of electricity, heat and electricity, they're sonorous, they have high melting and boiling point. Now, malleable means you can beat them down into thin sheets. Ductile means you can draw them into wires. You can draw them into wires, okay, and malleable mean you can beat them into sheets. That is malleability. They are good conductor of electricity, they produce sound, and they have high melting and boiling point. There are some exceptions to metals. What are those exceptions? Sodium and potassium, they are very soft. Mercury is liquid at room temperature. Cesium, gallium, they have really low melting point, yet all these are metals, right? Similarly, for non-metals, they are soft, brittle, dull, they are bad conductor of electricity, but again there are exceptions. Iodine is highly lustrous, graphite is good conductor of electricity, and diamond is extremely hard. Okay, these properties contradict, right? That's why they come under the exceptions category. Next, the reactivity series. Let's start with that. This is one way of remembering the reactivity series. Please stop calling me a careless zebra. Instead, try learning how copper saves gold, platinum. So please, potassium, stop sodium, calling calcium, me magnesium, A aluminum, careless carbon, zebra zinc, instead iron, try tin, learning lead, how hydrogen, copper, silver, gold, platinum. Okay. Now, my dear students, this is the decreasing order of reactivity. This is the decreasing order of reactivity. Decreasing order of reactivity of metals. As you go down the reactivity series, the reactivity of metals decreases. Okay, this metal is highly reactive, then potassium, sodium, calcium, magnesium is highly reactive, then these are metals of moderate reactivity, zinc, iron, lead, tin, and these are metals of low reactivity, hydrogen, copper, silver, and these are metal of non-reactivity. Okay, now let's start with the chemical reactions. Chemical reaction of metals. The first is metals react with oxygen, and when metals react with oxygen, we get metal oxide. We just discussed it. Metal oxides are basic in nature. Why? Because when you add water to a metal oxide, you will get a base. That's why metal oxides are basic in nature. While some metal oxides can be amphoteric. Amphoteric means they will react with both acids and bases. Next, displacement reaction. Okay, a displacement reaction, a more reactive metal displaces a less reactive metal from its compound. Displacement reaction, right? So one more thing, in the reactivity series, let's take an example of aluminum and zinc. As aluminum is lying above zinc in the reactivity series, it is more reactive. So any metal or element lying above the other element, it is more reactive. Above ones are more reactive, below ones are less reactive. Comparison, zinc and iron, zinc is more reactive, zinc can displace iron from its compound. Iron and tin, iron is more reactive, iron can displace tin from its compound. Tin and lead, tin is more reactive, tin can displace lead from its compound. Okay, that's why this series is very important. Next is, how do metals react with acids? We have three acids: sulfuric acid, hydrochloric acid, and nitric acid. So with sulfuric acid and hydrochloric acid, the reaction is simple. Metals react when metals and acids react, we get salt plus hydrogen gas. We get salt plus hydrogen gas. But with nitric acid, the thing is little different. With nitric acid, my dear students, as nitric acid is a strong oxidizing agent, it will convert this hydrogen straight to water. It will convert this hydrogen to water. There will be no hydrogen gas evolved when dealing with nitric acid. When metals react with nitric acid, no hydrogen gas is evolved. Only water molecule is formed. Two metals are exceptions, magnesium and manganese. These two metals evolve hydrogen gas when treated with nitric acid. Okay, then what is aqua regia? Aqua regia is a 1:3 mixture of concentrated nitric acid and concentrated HCl. 1:3, 1 part concentrated nitric acid, 3 part concentrated hydrochloric acid. It is royal water. It is called royal water as it is used to dissolve, as the purpose of making it is to dissolve gold, silver and platinum articles. Okay. Next is reaction with water. Metals react with water in depending on the reactivity. If a metal is highly reactive, they will react with cold water. If a metal is of low reactivity or middle reactivity, they will react with either water vapors. They will react with hot water. And if a metal is of low reactivity, they will react with water vapors. And if there are some metals, lead, copper, silver, gold, they do not react with any kind of water, hot water, cold water, water vapors. Clear? So when metals react with cold water, they produce metal hydroxide plus hydrogen gas is evolved, and lots of heat is also evolved for the metals which are lying at the top of the reactivity series. Sodium, potassium, magnesium, these metals react. Sodium, potassium, calcium, these metals react vigorously. Calcium does not react vigorously actually. Calcium makes calcium hydroxide and hydrogen gas is evolved, but here the hydrogen gas will not catch fire. For these metals, sodium, potassium, it will catch fire. Why? Because they are so reactive. The reaction is highly exothermic. Lots of heat is released. And when hydrogen combines with this heat, what will happen? We will get an explosion. Okay. Now, some metals which are in the low reactivity, like magnesium, they will react with hot water and form metal hydroxide, and again hydrogen gas is released. Then you have water vapors. Some metal react with water vapors, like aluminum, iron also react with water vapors, right? Water vapors have a higher temperature. You have hot water, which is like 70, 80 degrees, 90 degrees Celsius. Water vapors are formed above 100 degrees Celsius. The temperature is very high. This is for metals of low reactivity, right? Aluminum, iron, right? They will react with water vapors. And what we will get? Metal oxide. We will get metal oxide, not metal hydroxide. Why not metal hydroxide? Because metal hydroxide is not stable at higher temperature. At higher temperature greater than 100 degrees Celsius, metal oxide is stable. That's why metal oxide is formed, not metal hydroxide, right? And then there are metals, lead, copper, silver, gold. They do not react with hot water, cold water, water vapors at all. Next, reactions of non-metals. The chemical reaction of non-metal. First, simple. When non-metal combine with oxygen, we get non-metal oxide. Non-metal oxides are acidic in nature, but some non-metal oxides are neutral in nature. What are those metal oxides? Non-metal oxides. Carbon monoxide, nitrogen oxide, water. These all are neutral oxides. Okay. Clear? Non-metal oxide do not react with, there are not much reaction for non-metals because, you know, non-metals do not react with acid and they do not react with water also, because again, non-metals are not reactive, not more reactive than water or acid. They cannot evolve hydrogen gas. The reason is they cannot evolve hydrogen gas. as non-metals are less reactive than hydrogen. They lie below hydrogen in the reactivity series, okay? So as non-metals are less reactive than hydrogen. And thus cannot displace hydrogen from its compound. What compound? Hydrogen forms acid, right? HCl, H2SO4, right? Okay. Now, how do metals and non-metals react? When metals and non-metals react, we get an ionic compound, right? Because metals want to donate electrons, non-metal want to accept those electrons, so a bond is formed, and that bond is formed by transfer of electrons. That bond is formed by transfer of electrons. That is an ionic bond. An ionic bond is formed by transfer of electrons. It is very strong, okay? For example, here sodium has one extra electron, one electron in its outermost shell. If it loses this one electron, it will have a complete octet. So it will lose this electron, form a cation, right? Chlorine needs one electron to complete its octet. So it will accept this electron and will form Cl negative, an anion, right? And there is a bond formed between these, Na positive and Cl negative. The bond is ionic bond, and the compounds are called ionic compounds. What are the properties of ionic compounds? What are the properties of ionic compounds? They are crystalline in nature. They have strong force of attraction because the bond is formed by transfer of electrons. They have strong electrostatic force of attraction. There is a positive ion, there is a negative ion, right? There is a positive ion, there is a negative ion. They are brittle and they can be broken down by applying pressure. They have high melting boiling point. They are good conductor of electricity in molten state and in aqueous solution, and they are readily soluble in water and insoluble in solvents like kerosene, petrol, etc. Why? Because again, ionic compounds, they have charges, positive, negative ions, right? They're made up of cation and anion. And my dear students, they will only be soluble in polar solvents, which has these ions, positive, negative ions. Okay. Now, minerals versus ores. What are minerals? So minerals are compounds which occur in our earth crust, right? They are the naturally occurring elements or compounds in our earth crust. They are minerals. For example, salt, clay, marble. Now, ores are also minerals, but from ores you can extract the metal profitably and conveniently, okay? Because they have metals, right? They have metals, they have minerals, right? So what we want to extract those metals. So the quantity or the substance that is used for extraction is ores. Ores are those minerals which contain a very high percentage of particular metal, right? From which you can extract the metal profitably and conveniently. For example, bauxite, it is an ore of aluminum. Hematite, it is an ore of iron. Sodium's ore is rock salt, okay? Then we have gangue. What is gangue? Gangue is gangues are unwanted impurities that are present in the ores. Gangues are unwanted impurities present in the ores. They are called gangue, right? Like soil, sand, any dust, rocky particle, they are gangue. Now, how do you extract ores, right? How do you extract ores? So, based on the reactivity, according to the reactivity series, we classify them in three categories: metals of high reactivity, metals of medium reactivity, moderate reactivity, and metals of low reactivity. So, from potassium till aluminum, we have metals of high reactivity. From zinc, iron, lead, metals of moderate reactivity. Copper, mercury, silver, metals of low reactivity. And gold, platinum are not reactive at all. So, the more reactive element will form compound. They will not exist in their free state. They will form compounds and will exist as in their compound form only. But if metal is less reactive, like gold, platinum, they will exist in their native state. Basically, they will exist as gold and platinum only, okay? They will exist as gold and platinum only, okay? Now, based on the reactivity, we have some methods to extract ores. So, if metal is of high reactivity, we do electrolysis, we do electrolytic reduction. What do? We do electrolytic reduction, and that's why we get pure, that's how we get pure metal. If metals are of moderate reactivity, this is moderate reactivity, Okay, if metals are of moderate reactivity, they will be present as their sulfide or their carbonate ore. From carbonate ore you extract them using calcination. What is calcination? When you heat carbonate ore in absence of oxygen, it is called calcination. Roasting means heating a sulfide ore in presence of excess oxygen, that is called roasting. Okay, after doing both, after doing calcination and roasting, we will get oxide, metal oxide, and from that metal oxide we do reduction. What is reduction? Removal of oxygen. We remove the oxygen and that's how we get our metal. Purification, and that's how we get our metal. Okay. Now, concentration, there's one thing written here, concentration of ore. Concentration is nothing. Concentration means you remove the gangue particles from the ore. That is concentration of ore. Okay. Then metals of low reactivity, they will exist as sulfide ore. And how do you separate your sulfide ore? You extract metal by the process called roasting. What is roasting? Again, roasting is heating concentrated metal ore in presence of excess air. Okay, again, then you get the metal and you refine it. Okay, now my dear students, most awaited one, electrolytic reduction and electrolytic refining. Most of you get confused in this one. What is electrolytic reduction and what is electrolytic refining? So let me clear it for you once and all. Electrolytic reduction, it is a process that is used to extract metals. Extract metal from their molten compounds. Okay, so it is a extraction method. And which kind of metal you extract? You extract metals of high reactivity. We extract metals of high reactivity. So what is the process, my dear students? Like sodium, potassium, calcium, aluminum, they exist in the form of their chlorides. These metals exist in the form of their chloride. We melt them, molten chloride we take. Okay, molten chloride, right? And then we pass electricity through it. When we pass electricity through it, on the cathode, sodium will go on the cathode, and on the anode, chlorine gas will go on the anode. So reaction happens like this actually. If we have 2 Cl negative, we get Cl2 plus 2 electrons. Now these Na positive combine with the electron, and we get Na. And that's how we get our pure, we extract our metal. This reaction is happening at anode and this reaction is happening at cathode. Okay, so what is electrolytic reduction? It is a process used to extract metals of high reactivity, right? Like sodium, potassium, calcium, magnesium, aluminum, calcium, magnesium. Okay, how do you extract it? You have this setup, you melt the first step, melting of the chloride. You melt the chloride, molten chloride you have, right? Then you pass electricity through its solution. We pass electricity. At anode, chlorine gas is formed, and at the cathode we get our sodium metal. Then again we purify it and we get our pure metal. Refining is done later on. Next technique is electrolytic refining. In electrolytic refining, my dear students, it is a process of purifying. You already have a metal. You are not extracting. You do not have a compound. You already have the metal. What you are doing, you are just purifying that metal. That means refining that metal, okay? Using electricity for metals like copper, zinc, silver, gold. So what do we do? It is important. What do we do here? We have anode and cathode. So the impure metal rod, supposedly, we are trying to purify, we are trying to refine copper. So the impure metal rod will be copper. This is a copper rod. Anode will be the impure metal rod, which is copper rod. Okay, and the cathode will be pure metal rod. This is pure copper rod. Clear? Right? And then you pass electricity through it. One more thing is there. We have this solution, right? This is electrolyte. The solution is called electrolyte. And what is the solution? We have a soluble salt solution, which is copper sulfate solution. So my dear students, whichever metal you're trying to refine or purify, you make the impure metal rod of that metal as the anode, the pure metal rod as the cathode, and salt solution, a soluble salt solution of that same metal as the electrolyte. Okay, and when you pass electricity through it, what will happen? This impure metal rod, this anode starts breaking down, it will start breaking down and it will dissolve in this solution. The anode will dissolve in this solution. From the solution, an equal amount of copper will deposit on this. From the solution, an equal amount of copper will deposit on this cathode. Okay. So at anode, we have the impure metal rod, it starts breaking down, dissolve in the solution, dissolve in the electrolyte. From the electrolyte, an equal amount of copper will deposit on this cathode. Okay. And with time, what will happen? If you let the reaction happen for some time, you let the electricity pass for some time, 1 hour, 2 hours, what will happen? This rod will completely vanish, this anode will completely vanish, and this rod will be so thick, this thick. Okay. Why? Because all the impure metal has been converted to pure metal and it is deposited on this rod. Okay. And that's how you purify copper, zinc, silver, gold. Okay. Now let's start with the questions. Let's start with the questions. Tell me the answer of this one. Ma'am. Vibrant, what do you want me to repeat? Vibrant, what do you want me to repeat? Which topic? Electrolytic reduction or refining? I think you're talking about electrolytic refining, right? I'll explain it again. Okay, so electrolytic refining, once again, one of you asked it. Okay, so in electrolytic refining, it is firstly, it is a technique used to refine, used to purify an impure metal. You have already extracted the metal from its compound, you have just the metal which is little impure because of the impurities it have, rock, sand, dust and everything, right? So what you do, you make that as rod, that impure metal rod as anode and the pure metal rod as cathode. Okay, you immerse both of them in a solution of electrolyte. What is that electrolyte? It is a soluble salt solution of that same metal. Okay, and then you pass electricity through this setup. What will happen when you pass electricity? The anode will start breaking down. The anode will start breaking down. It will dissolve in the solution. It will go in the solution. From the solution, an equal amount of that metal will deposit on the cathode. Anode will break down, dissolve in the solution, and equal amount of metal from the solution will deposit on the cathode. Okay, with time what will happen? This rod will vanish, this anode will vanish completely, and all metal will be deposited on the cathode. Okay, now what is this? This is called anode mud, because this is the impurities, na? These are the impurities which were there in the impure metal. These were the impurities that were there in the impure metal, and we have separated them. This comes out as anode mud, and the pure metal will deposit on the cathode. I hope it is clear now. If you had anything else, you can ask me, but let's start with the question. A student places a clean strip of magnesium in a blue solution of copper sulfate. Firstly, you should have an idea which is more reactive, magnesium or copper sulfate. What is the expected observation? So my dear students, we know magnesium is much more reactive than copper. Magnesium is much more reactive than copper. Okay, magnesium, okay, and copper sulfate, which is more reactive. Magnesium is more reactive, right? And the product you will get is magnesium sulfate displacement reaction plus copper. So this is blue color, right? This is blue color. Over time, what will happen? The blue color will fade, right? The solution the blue color of the solution fade and a reddish brown solid is deposited on the strip. Why? Because you have a magnesium strip, you add that strip in copper sulfate solution, what will happen? Magnesium sulfate will form and copper metal get deposited, and copper metal get deposited on the magnesium strip. On the magnesium strip, copper metal gets deposited. Okay, I hope it is clear. So the answer is C. The blue color will fade, and because copper is reddish brown in color, the reddish brown solid will deposit on the strip. The reddish brown solid will deposit on the strip. Yes, the correct answer is C. Correct. Next question. Amalgam is an alloy of. So whenever you read amalgam, just remember one thing, one of the metal will always be mercury. One of the metal will always be mercury. So here check the option. Which option has mercury? Option B has mercury. So that means correct answer is next question. Metal obtained from their molten chlorides by the process of electrolytic reduction. So firstly remember molten chloride and electrolytic reduction. That means we are talking about metal of high reactivity. Highly reactive metals we are talking about. Which is highly reactive metal here? Let's see. Gold and silver, they are not reactive. They are not reactive at all. They will exist in their native form only. Calcium, magnesium is one, sodium, iron, but iron is not extracted using electrolytic reduction. So the correct answer is calcium, magnesium, right? Because you extract both of these metals using electrolytic reduction. The correct answer is option B. Yes, some of you answered B. Next question, the pair which will show displacement reaction. So displacement reaction will be shown by the pair NaCl and copper. Let's see, Na and copper. Sodium is more reactive, it won't displace. Copper will not be able to displace sodium from its compound. Silver and copper, again copper is more reactive than silver, right? Yes, copper is more reactive than silver. Copper will displace silver from its compound. This will happen. Aluminum and magnesium, again so magnesium is more reactive than aluminum. Yes, so that means this reaction will also happen, right? Zinc and iron, again iron is not more reactive. Iron is less reactive than zinc. This reaction will not happen. Iron will not be able to displace zinc from its compound. The correct answer is 2 and 3. 2 and 3, which is option B. Next question. The solution of ionic compound are good conductor of electricity. That is true. Correct. Why? Because, let's add a because and then check the reason. Movement of atom of element take place in solution. No. Ionic compounds are good conductor of electricity because they have ions. The reason is ions, right? So that means assertion is true, but the reason is false. The metal produced by various reduction processes are not very pure. They contain impurities which must be removed to obtain pure metal. The most widely used method for refining impure metal is electrolytic refining. We just discussed it. What is the cathode and anode? Cathode, let's say we are refining copper. So cathode will be pure copper rod, and anode will be impure copper rod. Name the solution used in the above process and write its formula. The solution is copper sulfate. How copper gets refined when electric current is passed? Again, if we pass electricity, anode will start breaking down and it will dissolve in the solution. From the solution, an equal amount of copper will deposit on the cathode, and that's how you get your pure metal. That's how we refine it. You have 2 beakers containing copper sulfate. What would you observe to are, if you dip zinc in one and silver in the other. So as we know, zinc is more reactive than copper, but copper is more reactive than silver. That means, that being said, my dear students, in beaker A and beaker B, in beaker A there will be a reaction, in beaker B there will be no reaction, because As silver is less reactive than copper, it cannot displace copper from its compound, copper sulfate, okay? So reaction will happen in the beaker A, which has zinc, but no reaction will happen in beaker B, which has silver. Okay, next question. The ability of metals to be drawn into thin wire is known as... I just did. Where were you? I just did electrolysis and electrolytic reduction. Both I did. Wait, you want me to do electrolysis? Okay. Thin wire is not malleability, it is ductility, Neelam. The answer is ductility. The answer is ductility. Okay. Now see, my dear students, electrolysis means using electricity we are decomposing, right? Decomposition is done using electricity. If you pass electricity through a solution of through water, right, acidified water solution, what will happen? It will decompose into hydrogen and oxygen. Okay, it will decompose into hydrogen and oxygen. At cathode we will get hydrogen gas, and at anode we will get oxygen gas. Okay, and what are we providing? We are providing electricity. And one more thing is there, this water is acidified. That means a few drops of acid are added to it. Few drops of acid are added to it. Okay, and the answer is ductility. Next question. Aluminum is used for making cooking utensils. Which of the following properties of aluminum are responsible for the same? So for cooking utensil you need two things. Again, it should be able to you should be able to heat it to a very high temperature. That means it should have high melting point, right? And the gas should not be wasted, right? If you heat it, it should be able to conduct all that heat. So that means good thermal conductivity. Okay, 1 and 4. The correct answer is option D, right? That's a common sense question. Next question, which of the following oxide of iron would be obtained on prolonged reaction of iron with steam? So when you heat iron for a longer period, prolonged time, firstly it will make iron oxide Fe2O3, but if you prolonged reaction with steam, water vapors, we will get Fe3O4. We will get Fe3O4. Alloys are homogeneous mixture of a metal and a metal with a metal or a non-metal. Which among the following alloys contain non-metal? So you see, brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. Amalgam has mercury plus any other metal. Steel is an alloy of iron and carbon. Carbon is a non-metal. Carbon is a non-metal. So that means the correct answer is option D. Next question. Some metal oxides are amphoteric in nature. Why some metal oxides are amphoteric in nature? Because metal oxides show acidic behavior. Reason is incorrect, but as you can see, yes, some metal oxides are amphoteric. Metal oxides can be either amphoteric or they can be basic. Non-metal oxide can be acidic or neutral. Remember this. Metal oxides can be basic or amphoteric. Non-metal oxides can be acidic or neutral. Okay. So yes, the assertion is true, but the reason is false. Assertion is true, but the reason is false. Okay. Answer the next question. P is found in form of its compound, Q is found in free state, which is nearer to the top. So if a metal is found in form of its compound, that means it is highly reactive. It is reactive. It reacted with the compound around other atoms around it and formed a compound, right? So if P is existing as a compound, so that means P is more reactive. P is more reactive, right? And if Q is existing in its free state, that means no compound is formed, right? So that means Q is less reactive. Clear? Hello, hello. Am I audible to you all? Okay, let's start. We have done this question. Let's move on to the next question. A green layer is gradually formed on a copper plate left exposed to air for a week in the bathroom. What could be this green substances? So simple, we know copper gets corroded in presence of carbon dioxide. The reaction is copper combines with oxygen, forms copper oxide, and this copper oxide on combination with carbon dioxide forms copper carbonate, which is the reason of green color. Green color, okay? This is the reason for the green color of copper, okay? That is the corroded. Copper gets corroded into copper carbonate. Next question. Same question, I think it again. Okay, we have done this one. A metal reacts vigorously with water to form S and the gas G. So from here we get our hint that a metal reacting vigorously with water, that is sodium, right? Okay, it reacts with water to form a solution S and a gas G. So it combines with water to form a solution S and gas G. The solution S turns red litmus blue. That means the solution S is base. Whereas gas G, which is lighter than air, burns with a pop sound. That means the gas is hydrogen gas. Metal M has a low melting point and is used as a coolant in a nuclear reactor. Even if you do not remember, do not know these things, you can answer based on the above 3 lines only, okay? Whenever you're answering questions, my dear student, this should be your strategy, whatever you remember. Whatever you remember. See, I started from the first line, rigorously with water, right? Using a pencil that could be could be sodium, right? Because it reacts vigorously with water. Then it forms a solution S and gas G. So if we treated sodium with water, we get sodium hydroxide and hydrogen gas, okay? Now this solution S turns red litmus blue. That means it is a base, right? So solution S is a base, yes. And gas G is lighter than air and burns with a pop sound. This is hydrogen. Pop sound, only one gas is there which burns with a pop sound. That is hydrogen. So metal M is sodium. The solution is sodium hydroxide and the gas is hydrogen. Okay, I hope it is clear. Let's move on to the next question. Metal in the reactivity series high up, they are very reactive. They cannot be obtained. Okay. Why can't we reduce oxide of sodium by using carbon? Because sodium has high affinity for oxygen. Sodium reacts strongly with oxygen. It won't react with carbon in that speed. Nope. It reacts vigorously with sodium and forms sodium oxide. Right? It is highly reactive. Molten chloride. So firstly you melt. How that is electrolytic reduction. The process is electrolytic reduction. Let me just explain it, show you the diagram though. Let me just show you. Electrolytic reduction. So in electrolytic reduction, you see you have first step is melting NaCl. You melt the NaCl, molten NaCl you have, right? And in that molten NaCl, you have one anode, one cathode. Both are made up of graphite. Both are made up of graphite, inert electrode. And then you pass electricity through it. What will happen? Sodium chloride, okay? Sodium will go to the cathode and chlorine will go to the anode. This is the reaction. This is the whole process. Nothing. Melt the NaCl, then you after melting it, you put it in the solution, and then after that you pass the electricity through it. If you pass electricity through it, the chlorine gas will go to the anode and sodium will deposit at the cathode. This is the method of purification, method of extraction of sodium actually, okay? Yep, so we were on this question. Right, one reaction where carbon is used as a reducing agent. This very simple one. You have zinc oxide, and if you add carbon, we get zinc and carbon monoxide. Clear? Why we use molten sodium chloride, not aqueous? So my dear students, when we have aqueous sodium chloride, there is one problem. There is one problem that if you have sodium chloride and if you have water with it, so at Na positive and H positive, these two ions will be there, right? Na positive and H positive will compete for the cathode position. Yes, they will compete for the cathode position, right? So you do not want that. We do not want that, right? We want sodium only. We do not want hydrogen on the cathode, right? So that's why we do not use aqueous solution. We do not use aqueous solution. Why? Because in aqueous solution you have both hydrogen ion and sodium ion, and both will compete for cathode position, right? Both will compete for cathode, right? And we do not want that. We only want sodium to be deposited on cathode, okay? So that's why we do not use aqueous sodium chloride. We use molten sodium chloride. Okay. Next question. Study the following table. A is giving no reaction, then it is showing displacement with copper. That means A is more reactive than copper. B is showing displacement with iron. That means B is more reactive than iron. C is showing reaction with silver. That means it is more reactive than silver. And D is not reacting at all. It is the least reactive. The least reactive metal is D because it is not able to displace single salt. This is the condition, no? More reactive element displaces a less reactive element from its compound. Now, as D is not able to displace any element from its compound, it is not reactive at all. Okay. Now, the reactivity order will be D in order of increasing reactivity. D. Then after that, silver, copper, iron. Silver is the least reactive, that means C. Then copper is more reactive than silver, that means A. And iron is the most reactive among these, that means B. This is the correct order. Now, if you want to store zinc sulfate and silver nitrate in a container, the container should be of such metal which won't react with zinc or silver. The container should be made up of such metal which do not react with zinc and silver. So, which among the following do not react with zinc and silver? D, right? D does not react with zinc and silver. So, that means you can use it to store zinc sulfate and silver nitrate solution. Okay. Next question, an alloy may be defined as a homogeneous mixture of two or more metals or a metal and a non-metal. Yes, that is true. That is the definition of alloy. Reason, let's add a because and then try the reason. Because an alloy containing mercury as one of the constituent metal is known as amalgam. So, my dear students, yes, this is true, but the assertion reason are not same. If you add the because and you say the reason, it is not explaining the assertion, okay? It is not explaining the assertion, okay? So, what is happening here, my dear students? Both are true, but reason is not the correct explanation of assertion. The correct answer is option number B. Next question. The sulfide ores are converted into oxides by strongly heating in presence of excess air. Yes. What is that process? That process is called roasting. That is true, because let's add a because and then try to answer the reason. The sulfide ores are converted into oxides by heating above its melting point. Yes, the reason we use excess of oxygen because we want the temperature to be really high, so that sulfide ore gets converted into their respective oxide. So yes, both assertion and reason are correct, and the reason is the correct explanation of assertion. Last chapter of ours, which is carbon and its compounds. It is also one of the top scoring. Metal and non-metal, carbon and its compound. Focus on these topics first. Start with them. Finish these chapters first and then move on to the rest. Chemical reaction and equation, acid, bases and salts. Okay. Carbon and its compounds. Before we begin, let me just check your comments one. This is the last chapter. After that, we are free actually. Last chapter, almost done. Once we finish it, yeah, they are now. Okay, let's start then. Am I audible to you all? Okay. Yeah. Everyone, please focus. This is the last chapter and it is very important. So listen carefully. Okay. For language, I don't have any idea, but I don't think so there will be classes for language. Any doubt you have, anything you're facing during your exam season that you are, confused about in chemistry, in life, and you don't know how to deal with it? Yes, good. If you're focusing, I'm looking at you. You're focused. Nice. Okay. So if you have any doubt, if you want me to tell, if you want me to answer your doubts regarding chemistry, regarding any exam doubt you have, just ask me. I'll explain, because this is the last chapter and then we are almost done. Okay, let's start. Carbon and its compounds. So carbon, what is carbon, bro? Carbon has it has an atomic number of 6. Carbon has an atomic number of 6, right? It has a mass number of 12. It has 6 protons, 6 neutrons and 6 electrons, right? It has a valency of 4. The electronic configuration is 2, 4. It cannot lose 4 electrons and it cannot gain 4 electrons. Why it cannot lose 4 electrons? Because if it loses 4 electrons, it will form a duplet, right? But removing those 4 electrons is energetically unfavorable. Too much energy is required, okay? And then you have, if you wanted to gain 4 electron and complete its octet to 8, right? Seems nice, na? But it won't happen. Why? Because then you will have 10 electrons and there will be 6 protons. You will have 6 protons trying to balance 10 electrons. Seems like an impossible task, okay? Because it's very difficult. 6 protons trying to balance 10 electrons. So much electrostatic repulsion. So much repulsion between the electrons will be there, and there will not be sufficient attraction between the protons and the electrons, okay? So yes, neither it can't form cation, it can't form anion. What it does, it forms covalent bond. It forms covalent bond. That is, it shares its 4 electrons. Carbon share its 4 electrons and complete its octet. Right? Now let's talk about covalent bond. Covalent bond is a bond that is formed by sharing of electrons, not by transfer of electrons, but by sharing of electrons, okay? When metal and non-metal react, when metal and non-metal combine, we get an ionic bond, because metal wants to donate electrons, non-metal wants to accept electrons. When non-metal and non-metal combine, we get a covalent bond. That is a bond formed by sharing of electrons, okay? For example, hydrogen and chlorine. Hydrogen has 1 electron. Chlorine only need 1 electron to complete its octet, right? So they form this single covalent bond, okay? We'll go to that later. Similarly, carbon and oxygen. Carbon needs 4 electrons. Oxygen needs 2 electrons. Oxygen needs 2 because oxygen is what? 2, 6, right? Yes. So it will share its 2 electron with carbon. Similarly, this oxygen also will share its 2 electron with carbon, and carbon is also sharing its 2 electron with oxygen, both the oxygen, right? So we are getting double covalent bond. So we have 3 type of covalent bond. Single covalent bond, when only 1 electron is getting shared between 2 atoms. Double covalent bond, when 2 electrons are getting shared. Triple covalent bond, when 3 electrons are getting shared, okay? Now, what are the property of covalent compounds? As covalent bond is considered very weak, it is a very weak force, okay? So that's why they have low melting and boiling point, right? They are poor conductor of heat and electricity. Why? Because they have no free ions or electrons, right? Ionic covalent compounds are poor conductor of heat and electricity. Why? Because they have no free ions or electrons. They are soluble in organic solvents. Organic solvents like benzene, hexane, etc. These all are your organic solvents, okay? Again, they do not have any charge, no ions, no charge separation. So what is there? They will dissolve in only known polar compounds, or known polar solvents, or organic solvents do not have charge. Like dissolves like, right? So yes. Allotropes. What are allotropes? So allotropes are different structural forms of same element in the same physical state. Structural forms. That means they are made up of same element, carbon. In this case, they all are made up of carbon, but they will have different structural arrangement, and due to that they will have different physical properties. Chemical reactions will be same. All the chemical reactions will be same, but the physical properties will be different. Why? Because of the different structural arrangement. Okay, they have similar chemical properties. There are three allotropes of carbon. Diamond, it's a crystalline allotrope. So in diamond, you see each carbon is bonded to here. Each carbon is bonded to 4 other carbons. 1, 2, 3, 4. Okay, it has this 3D network, and that's why it is so hard. Diamond is extremely hard. It is one of the hardest substance on our planet Earth. Okay, so each carbon is tetravalent. That means each carbon is bonded to 4 other carbons. Okay, and this give rise to, and due to that we have a 3-dimensional arrangement. It is very hard. Okay, it is not a conductor of electricity. It is not a conductor of electricity. Okay. Next allotrope is graphite. So graphite is an allotrope of carbon in which each carbon atom is trivalent. That means each carbon atom is bonded to 3 other carbons. Let's see here. It is bonded to 1, 2 and 3 other carbons. Okay, and we have hexagonal layers. Okay, it has this hexagonal array of carbon atoms. So the carbon atoms, firstly they are trivalent. Each carbon atom is bonded to 3 other carbons, and then we have these hexagonal layers that are stacked above each other. Okay, they are stacked above each other. There is this weak covalent forces between them, right? And because of that it is extremely soft. It is extremely soft because this force of attraction between the layers is very weak, and if you hit it with little force they will slide straight away. Because of that reason they are really soft. Okay, each layer is far apart because you have weak van der Waals forces in between the layers. Okay, next thing, each carbon atom is trivalent, that means one free electron is there, and due to that one free electron they are good conductor of electricity. They are good conductor of electricity. Next allotrope is Buckminster Fullerenes. Its formula is C60, right? It has this football-like shape, and basically it resembles a building in USA which has this dome-like structure, and so the name is based on the name of the architect who made that building. Okay. Next we have hydrocarbons. What are hydrocarbons? So hydrocarbons are compounds, organic compounds that are made up of hydrogen and carbon, right? We have two type of three actually: saturated hydrocarbon, unsaturated hydrocarbon, and cyclic hydrocarbons. Saturated hydrocarbons are those hydrocarbons in which each carbon atom is singly bonded. It has carbon-carbon single bond and carbon-hydrogen single bond. Okay, when each carbon-carbon atom is singly bonded, that is saturated hydrocarbon. For example, alkanes. General formula of alkanes is CnH2n plus 2. Unsaturated hydrocarbons means when compounds have double or triple bond. So either C or C double bond or C or C triple bond. Carbon-carbon double bond or carbon-carbon triple bond will be there. That is unsaturated hydrocarbon. Okay, the general formula: alkenes and alkynes. Alkenes and alkynes are unsaturated compound. The general formula is CnH2n and CnH2n minus 2. 2n minus 2. Next is cycloalkanes. Cycloalkanes are similar to alkanes. Each carbon atom is singly bonded. Each carbon bond is single bond. Okay, but there is a ring present. Okay, there is a ring. Okay, so you have each carbon single bond, but each in the end the last carbon atom will be bonded to the other to the first carbon atom, and there will be kind of a cyclic ring formation. That is a cycloalkane. This is one, This is cyclohexane. Clear? So the general formula is CnH2n. I hope it is clear. Homologous series. What is homologous series? Homologous series is a series of organic compounds which have same functional group, same general formula, same chemical properties, different physical properties. They differ in physical properties, as in they will show gradual change. Either the physical properties will increase or the physical properties will decrease. Okay. Next, each successive member differ by CH2 unit. These are all. Homologous series have same functional group, same general formula, successive member differ by CH2 unit, and they show similar chemical properties, and they show gradual change in physical properties. Okay. For example, we have here alkane, alkene, alkyne, haloalkane, alcohol, ether, aldehyde, ketone, carboxylic acid. These all are the members of homologous series. Okay. This is one homologous series, alkane. Second is alkene. Third is alkyne. Then you have haloalkane. Alcohol is also one homologous series. Then you have aldehyde and ketone. Now, how do you name hydrocarbons? So let's start with a basic example. Okay, so you start by the longest carbon chain. Let's start with the longest carbon chain. So in here we have 1, 2, 3, 4, 5 carbon, and if we go 1, 2, 3, 4, 5 carbon, and if you go down 1, 2, 3, 4 carbon, this is not a longest one. 5 carbon is greater than 4, right? So we'll take this longest chain. Okay. So we'll start from here, 1, 2, 3, 4, 5. Now see, at 3 we are having this methyl group. This is a methyl group. So at 3 we have methyl. Okay. So the name will be 3-methyl. Firstly, you name the substituent. Then after that, parent chain. The root name of the parent chain. We have 5 carbon. The root name is pent. The root name is pent, and the functional group, as all the bonds are single bond, each carbon-carbon bond is single bond, so you name alkane. It is an alkane. So the name is 3-methyl pentane. Do not overcomplicate it. This is the sequence. Prefix, substituent, whatever the substituent is, firstly you write the name of that substituent, then you write the word root. Okay, the word root is the longest carbon chain, the number of carbon in the longest carbon chain. Okay, and then after that you write primary suffix, secondary suffix, that is depending on the functional group. If we had just one functional group here, which is alkane, so we write ANE, just one. Suffix means it's coming after the name, prefix means it's coming before that. Okay. Now here are some common functional groups that you will be seeing. Alcohol, the suffix is all. Ketone, this is the functional group, ketone. So here are 2 alkyl groups on each side, that is a ketone, and the suffix used is -one. For aldehyde, again same, it looks similar, no? But here one, instead of both alkyl group, we have one hydrogen on one side, and other side we have alkyl. That is aldehyde. The suffix used is Al. Then you have carboxylic acid, RCOOH. This is the functional group, COOH, and the suffix used is oic acid. Suffix used is oic acid. For alkane, ane, alkene, ene, alkyne, YNE. That is the suffix. These are the suffix. You have one more actually. We have this one, haloalkanes. So they have RX. This is their formula. X can be fluorine, chlorine, bromine, iodine, right? Okay. Now see, what will be the name? In this case, you will add a prefix. In this case, you will add a prefix which is halo. Halo is the prefix, and then after that you write the functional group suffix. Then you write the suffix whatever you have, haloalkane if you have, haloalkene, haloalkyne, whatever it is there. Okay. So in this case we use prefix. For the rest we use a suffix. Okay. Now, what are the chemical reactions shown by carbon compounds? So carbon compounds show majorly 4 reactions: combustion, oxidation, substitution and addition. What is combustion? So combustion means you're burning something, right? You're just providing oxygen and you are combusting. What you are getting in return, you are getting heat and light. Okay, when you light up a pile of wood also, you get heat and light, right? That is combustion. Okay, so combustion is addition of oxygen, but the supply is not limited. An unlimited supply of oxygen you are providing, and in result you are getting heat and light. Carbon dioxide, water will be there, but you are getting heat and light. So whenever you are combusting any hydrocarbon, alkene, alkyne, alkane, alkane, alkene, alkyne, they will give the same result, carbon dioxide and water. Carbon dioxide and water. Oxidation, oxidation means addition of oxygen. You add one more oxygen. So for example, if you do oxidation of alcohol, these are the oxidizing agent, alkaline KMnO4 or acidified K2Cr2O7. So if you oxidize any alcohol, we get a carboxylic acid. Okay, from alcohol we get a carboxylic acid. Clear? Next is substitution. Substitution reaction is shown by saturated compounds. Saturated compounds show substitution reactions. So saturated compounds are those compounds again in which all the carbon-carbon bonds are single bonds. Each carbon is bonded, has a single bond with the other carbon. All carbon-carbon bonds are single bonds. Okay. So here what you can do, you cannot add a new compound. Basically what you can do, you cannot add a new bond, right? Because each carbon atom is singly bonded to 4 other carbon atoms or 4 other atoms. Okay. So what you can do here, you can substitute it. You already have an atom. What you can do, you can substitute that atom. Supposedly I had an hydrogen here. What I did, I substituted that hydrogen with chlorine. Chlorine came, hydrogen left, right? CH3Cl is formed. Okay. So substitution reaction is shown by saturated compounds. Addition reaction is shown by unsaturated compounds. Addition reaction is shown by unsaturated compounds. Clear? Now unsaturated compounds are those compounds which have either double bond or triple bond. Carbon-carbon double bond or carbon-carbon triple bond. They are unsaturated compound. So in unsaturated compound you have a possibility that you can break this one bond because they are weak. You can break this one bond or this one bond, and what you can do, you can add any other new atom. Add any new atom. For example, this reaction is hydrogenation, or you can say catalytic hydrogenation. It is very important. So in catalytic hydrogenation, you have an alkene and any unsaturated compound you have, and in unsaturated compound you added hydrogen in presence of nickel, platinum, palladium catalyst, nickel catalyst, okay, and you get a saturated compound, right? So this method is generally used for converting unsaturated vegetable oils into saturated fat. Unsaturated oil into saturated fat. Okay, this process is called hydrogenation, catalytic hydrogenation. Okay. Now there are chemical properties of ethanol and ethanoic acid. Okay, let's start with the chemical properties of ethanol and ethanoic acid. This is ethanol, right? And this is ethanoic acid. Clear? So ethanol shows this reaction. So when ethanol is treated with combustion of ethanol, first of all, you know ethanol also burns. Whenever you burn ethanol, it gives that blue flame, so clean flame that you can't even see the fire. Okay, is the invisible fire. So when you combustion means you are providing oxygen, right? You are providing oxygen, you get carbon dioxide and water. The product is same. When ethanol reacts with sodium, we get sodium ethoxide. Sodium ethoxide and a hydrogen gas is evolved. That is important. Hydrogen gas is evolved. Okay, and now you can test it. It can be used as a test for ethanol. You can test the presence of ethanol, okay, by adding sodium metal to it. If you have a solution of ethanol, you add sodium metal to it, you will get sodium ethoxide and hydrogen gas is evolved. Okay, now ethanol also undergo oxidation, we just did, right? Alcohol undergo oxidation, and what do we get? We get carboxylic acid. We get carboxylic acid. When ethanol undergo oxidation, we will get ethanoic acid. Dehydration of ethanol, when you heat ethanol at around 443 Kelvin. When you heat ethanol at around 443 Kelvin in presence of hot concentrated sulfuric acid, ethanol gets converted into ethene. Ethanol gets converted into ethene. Now, ethanoic acid, what reactions does ethanoic acid show? First is reaction with sodium, same. We get sodium ethanoate. This is sodium ethanoate. Remember these names. That is sodium ethoxide. There is one oxygen less. This is sodium ethanoate. Again, hydrogen gas is also evolved. How do carboxylic acid or ethanoic acid reacts with sodium hydroxide? An acid and base. What do we get? Salt and water, right? Salt and water. What kind of salt is this? It is a basic salt. It is a basic salt because sodium hydroxide is a strong base. Okay. How do ethanoic acid react with sodium carbonate, sodium bicarbonate? Same reaction. We will get a salt plus water and carbon dioxide gas is evolved. Which gas is evolved? Carbon dioxide gas is evolved. Next is esterification and saponification. What is esterification? When alcohol, any alcohol and carboxylic acid, when alcohol and carboxylic acid reacts in acidic medium, an ester is formed. When alcohol and carboxylic acid reacts in acidic medium, an ester is formed, and that is called esterification. Simple. If you reverse this reaction, you get saponification reaction. Okay. Simply, if you want to memorize it actually. So, OH from the carboxylic acid and H from the alcohol. OH from the carboxylic acid, H from the alcohol, they combine and form water. Okay. Next is saponification reaction. In saponification reaction, you have an ester. And you add, it is the reverse actually. So what are you doing? You are treating the ester with a base. If you treat ester with a base, what will happen? We will get alcohol and sodium salt of carboxylic acid back. This is sodium salt of carboxylic acid. Okay. This is saponification reaction. Okay. Next is how do you test to distinguish between ethanol and ethanoic acid? So that's very simple. First is litmus test, because we have an acid turn blue, litmus red, and ethanol will show no reaction. Sodium carbonate test. In case of sodium carbonate, again ethanol will not show any reaction, but ethanoic acid will evolve carbon dioxide gas with brisk effervescence. What is brisk effervescence? Brisk effervescence means bubbling of carbon dioxide, bubbling of any gas molecules in a liquid solution. If there is bubbling of gas molecules there, it is called effervescence. Okay. Soaps and detergents. What are soaps, my dear students? So soaps are sodium or potassium salt of long chain carboxylic acid. They only work in soft water, because in hard water they form this insoluble substance called scum. This is the soap. It has a hydrophobic tail and a hydrophilic head, which means water loving head and a water hating tail, water fearing tail. Okay. Then we have detergents. Detergents have ammonium or sulfonate salts of long chain carboxylic acid. They work both in soft and hard water. What is scum? Scum is as hard water has magnesium and calcium salt, right? Hard water has these magnesium and calcium ions. So soap combines with those magnesium and calcium ions and form this insoluble precipitate or product called scum. That is scum. Okay. That's why you do not treat soap in hard water. This is missile. What is missile? So if you have an oil particle, around that soap molecules will align themselves in such a way that their hydrophobic part is pointing towards the oil particle and the hydrophilic part is outside pointing towards the water. Okay. And yes, that's how you remove the impurities and you agitate it. Okay. then you agitate it physically, you beat clothes, or in washing machine you agitate it, and that's why we wash away this missile with excess water. This is missile. This is missile. Okay. Now let's start with questions, my dear students. What questions you want? Here are the questions. Let's start with them. Missile you want me to explain again? Okay. So missile is actually this when you have oil or grease particle that is lying on your clothes. So around that grease particle, when you put soap or detergent, so what happens? These are soap or detergent molecules. They have the same structure. Okay, they have a hydrophilic head and a hydrophobic tail. That means a water-loving head and a water-fearing tail. So these soap molecules align themselves in such a way around the oil particle, that their hydrophobic tail, their water-fearing tail is pointing towards the oil particle, and the hydrophilic head, the water-loving head, is pointing towards the water surface. Okay, outer side, water side. Okay, now all of these align themselves and then they form this missile. White color, I don't know if you have seen it. When you wash clothes, you have this white form or something, right? That is missile. This formation is called missile. And if you agitate your clothes, if you physically beat them or agitate it in washing machine, they will wash away. It will wash away. With excess of water, you can wash it away. That is missile, and that's how you remove it from your clothes. Okay, this is missile. Simple. The arrangement, this is the drawing. Oil particle, you can say this is the hydrophilic head and this is the hydrophobic tail. Okay, let's start with the question. You answer this question. Covalent bonds do not have strong force of attraction, first of all. What are you comparing them with? With van der Waals force, if you are comparing, yes, they are strong. But covalent bond in general, they are weak. Intermolecular forces are also the same. Intermolecular forces are also same. In between molecules you are talking. Intermolecular means in between molecules. Your statement is incorrect actually. It's a contradictory statement. It's not a correct statement. What you can say, okay, covalent bonds are weak bonds because the intermolecular force of attraction forces are weak. Okay, they're not strong force of attraction. They're just formed by sharing of electrons. Yeah, ask me, you. I'm listening. Bleaching powder, yes, so use that now. This is the formula you use. Whatever is written in NCERT, CBSE blindly trust them because your answer key is made from NCERT only. Okay, so if you are writing any answer, anything you're writing in English, in SST, in science, okay, use the NCERT keywords. Use the NCERT language, my dear students. If this is written in NCERT as the bleaching powder, use it, okay. Do not change it. So one more thing, my dear students, yes, imposter formulas, you are not able to remember it. I know. I have made a formula sheet. I have made actually. In the description, you will find the physics formula sheet, the chemistry reactions, and the biology diagram. So you can download it straight from the description of this live only. Okay. And yes, the answer is A. Formula, chemical formula you are talking, so I have made a video on that too with all the important chemical formulas. You can go check it out once. Okay. Assertion says covalent compounds like methane and ethanol generally have low melting and boiling points. Why? You add a because again. The intermolecular force of attraction between the molecules of covalent compounds are very weak. See, this is the correct statement. What were you asking? Who is Priyanka Static? I don't know. Guys are just chatting. So see, covalent compounds like methane and ethanol, they have low melting and boiling point. Why? Because the intermolecular force of attraction, which is covalent bond, is very weak. Yes, that means both assertion and reason are true, and reason is the correct explanation of assertion. What is this? Shame. Yes, that is yes, that is correct. Whatever is written in your textbook, follow that. Okay. Most of you had doubt about the formula, that is CaClO and whole twice. Okay. Next question. So many questions we have. Okay, let's start. We have a lot to do. This chapter was important, so I added all the questions, I think. Now you quickly answer them, my dear students. If you answer them quickly, we will wrap up quickly. Yes, our questions. Aditi ma'am. Aditi ma'am's class is tomorrow, you know. Tomorrow morning, I believe. It's in the live section. You can go check it. An aqueous solution of ethane can decolorize bromine water. There is one test. Bromine water test. Let's do that. So bromine water test is normally used for differentiation between saturated and unsaturated compound. Saturated and unsaturated compound. Okay. So if you have a saturated compound and you add bromine water to it, okay, there will be no change in color. What color, ma'am? Bromine water is reddish brown in color. Bromine water is reddish brown in color. Okay. Now, unsaturated compound, if you add bromine water to unsaturated compound, my dear students, what will happen? The color will fade. Yep, there will be no color. Yes, it will become colorless, from reddish brown to colorless. From reddish brown to colorless. That is the test. Now see here, ethene, it is an unsaturated compound. It will decolorize bromine water. That is correct. Because ethene is a unsaturated hydrocarbon, and it will readily undergo an addition reaction with bromine. Yes, correct. because if I added a because and then I said the reason, and if it made sense, if the reason completely explained the assertion, that means it is the correct answer. So the correct answer is option A. How many of you answered option A? You're just sharing your home location now. Wow. Next question. Assertion says butane 1-ol and butane 2-ol exhibit similar chemical properties. Yes. Why? Because they have same functional group. All. That means both have same functional group. Alcohol. Let's add a because and try to answer the second part. Till then you answer the question, my dear. Hemant, are you studying? Reason is because they belong to the same homologous series of alcohols and possess the same functional group OH. Yes, that is the reason. Yes, because they have same functional groups. Same functional groups will show same chemical properties. So that means again the answer is A. Both are true and reason is the correct explanation of assertion. Can I send my message? Yes, please do. At least I have some idea who is studying and who is not. I see you all people. You are just here for fun though. You are not here. You are here to share your Instagram and Snapchat. Wow. Wow, wow, wow. Yes, your exams. In exam, write that only. Nice. Next question. Assertion says the complete combustion of hydrocarbons like methane produces carbon dioxide in water, which is correct. We know when you do combustion of methane, we get carbon dioxide and water. Why? Because the incomplete, if you add a because and you try to explain the, assertion using the reason, because the incomplete combustion of hydrocarbons in a limited supply of air can produce carbon monoxide. Actually, my dear students, both statements are true, but reason is not the correct explanation of assertion, because we are talking about complete combustion in this one. In assertion, we are talking about complete combustion, while in reason, we are talking about incomplete combustion. So that means the statements are contradictory. The reason does not explain the assertion. Okay. So the correct answer is both are true, but reason is not the correct explanation of assertion. And did anyone answer B? Can I get a B? You don't have. Yeah, nobody answered B. Next question. Alkanes are generally considered chemically unreactive or paraffins. Why? Because they have carbon-carbon single bond, and single bond is a little tougher to break. Because, let's add a because. Alkanes are saturated hydrocarbons containing only strong carbon-carbon single bond and carbon-hydrogen single covalent bond, which are difficult to break. Correct. That means both assertion and reason are true, and reason is the correct explanation of assertion. Okay, static, I see you. A. Yes, the correct answer is A. Correct you. Next question. Ethanol. So firstly, ethanol's reaction with complete combustion of ethanol. So if you do complete combustion of ethanol, let's balance it. 2 we need here. 5, 6 hydrogens here, so 3 we need here. Now 2, 4 and 3, 4 and 3, 7. So we have 6 and 1, 7. This is the balanced chemical equation. When ethanol is heated with excess hot concentrated sulfuric acid at 443 Kelvin, we will get ethene. We will get ethene. Okay? This reaction is called dehydration of ethanol. Reaction is called dehydration of ethanol. What happens when ethanol is warmed with ethanoic acid in presence of a few drops of concentrated sulfuric acid? So you remember this reaction is esterification. The reaction is esterification, right? When you have an alcohol, ethanol with ethanoic acid. So when you have an alcohol and carboxylic acid, if you treat them in presence of acid, here concentrated H2SO4, you get an ester. You get an ester, okay? This reaction is called esterification. In bromine case, equation won't be asked. First, the first thing, they'll ask only about the color. No reaction will they ask. But if you really want it, then I guess you can, yeah. For one thing, it will be like this, I think. This for unsaturated compound, because saturated will not give any reaction. They do not react with bromine. You wanted it, I gave it to you, okay? Next question, the presence of functional groups decide the properties of the carbon compound regardless of the length of the carbon chain. Yes, because the properties are decided by functional group. Yeah, functional group decides the properties of the carbon compound. Yes, the reaction it will undergo chemical properties, the physical properties also, but physical properties are majorly defined by the number of carbon present, okay? The reason is these all have same chemical properties. They do not, because they all belong to different functional groups. Alcohol, alkyne, alcohol, alkyne, alkene, alkane. Okay, this is alkane, this is alkene, this is alkyne, this is alcohol. All are different functional group, will show different chemical properties. This is not the correct answer. So the correct answer is C. Assertion is true, but the reason is false. Correct. Next question, assertion says ethanoic acid react with sodium carbonate to produce carbon dioxide gas with brisk effervescence. True. Yes, that is true. Reason is because all carbon organic compounds that contain a carboxylic acid are acidic in nature. Now, my dear students, reason is true, assertion is true, but is the reason correct explanation of assertion? Is the reason correct explanation of assertion? Nope, it is not. So that means both assertion and reason are true, but reason is not the correct explanation of assertion. Yes, the correct answer is B. Next question. Propanol has which functional group? Propanol, on, a ketone. That means ketone. This is propanol. See, this is propanol. Finally, assertion says soaps are not effective cleaning agent in hard water. Yes, they are not. True. Because soaps form insoluble precipitate, you add a because and say the reason. Because soaps form insoluble precipitate with the calcium and magnesium ions present in hard water. Correct? Yes, because in hard water we have calcium and magnesium ion, right? So yes, both assertion and reason are true, and reason is the correct explanation of assertion. Correct, you? Okay. A. Yes. Shankar also, Sanskar also answered A. Correct. Next question. When ethanol is heated at 443 Kelvin with excess concentrated sulfuric acid, ethene is obtained. Correct. Because concentrated sulfuric acid acts as a dehydrating agent. Yes. Because it acts as a dehydrating agent. Dehydrating means removal. Dehydration means removal of water. Dehydration means removal of water. Minus H2O, removal of water. Okay. So yes, both assertion and reason are true, and reason is the correct explanation of assertion. Next question. Two carbon compounds have this formula. Which of the following will show addition reaction? So my dear students, addition reaction will be shown by unsaturated compound, right? Now, which among these is unsaturated compound? Which among these is unsaturated compound? Let's see. C4H8, that means CnH2n. Yes, that is an alkene. C5H12, that means CnH2n plus 2, that is an alkane. So obviously alkane do not show addition reaction. Alkane show substitution reactions. Why? Because again they do not have space for accommodating one more bond. They already, all the carbon atoms are already tetravalent. They already have formed 4 bonds. Okay, so my dear students, alkene, because alkene, they have a possibility of breaking one bond, and in place of that bond you can add any other atom. Okay, so the correct formula is CnH2n. Yes, so this will show addition reaction. Next question, write the electron dot structure of methane and ethane. I'll just draw it. This is the electron dot structure. Dot, I am representing the electrons of methane, carbon, and X is the for hydrogen. This is the electron dot structure. Okay, so you draw it like this actually. And then yes, this is the electron dot structure of methane, right? 4 carbon, dot is the electron of carbon, X is the electron of hydrogen. Okay, now let's move on to the next one, ethane. Dot. Okay, we'll draw X again, X. Now see, 4 for this carbon, this for this carbon, and these also have completed their duplet. This is the electron dot structure of ethane. Okay, this is methane and this is ethane. Okay, next question, structure of micelle formed when soap is dissolved. My dear students, simple one. I'll just draw it. Oil, if you have a oil, around that soap particle will align themselves in such a way like this, that the hydrophobic tail is pointing towards the oil and the hydrophilic part is pointing outside. Okay, this is the structure of micelle. Next question, does not belong to the same homologous series. This is alkane. H8, this is also alkane. 6 plus 2, 8, right? C4H8, this is alkene. And C2H6, 4 plus 2, this is also alkane. So that means alkene, this does not belong to this particular homologous series, because alkane is 1 and alkene is also 1, not F, D. Yes, correct. Soap can work better. We already done this. Yes. So this is about burning actually. When you burn, you have 2 type of flame, yellow sooty flame and blue flame. So 2 things are there. So yellow sooty flame is generally obtained when you are burning unsaturated compounds, generally. When you are burning unsaturated compounds, or what are you doing? Or when you have a limited supply or less supply of oxygen. Less supply of oxygen. In that case, you will get yellow sooty flame. And when you are burning saturated compounds, or when you have plenty of supply of oxygen, then you get a blue flame. Okay, just remember it. You have 2 type of flame, yellow sooty flame, blue flame. Okay, so blue flame generally shown by saturated compound, and yellow sooty flame is generally shown by unsaturated compound, but that is not always true. Sometimes what happens, if you burn a saturated compound in limited supply of oxygen, they will give yellow sooty flame, right? You have seen that, right? Sometimes your gas thing, that holes get blocked and you will see yellow flame, right? And if you burn unsaturated compound, generally you get yellow sooty flame. But if you give pure oxygen, if you supply plenty of oxygen to unsaturated compound, it will burn with a clean flame. It will burn with a clean flame. Yes, what is your doubt? Tell me. No, 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 no. Not for benzene and sulfur. It is not in your syllabus, don't worry. Not for benzene and sulfur. Yes, any doubt you have, just ask me, okay? I'll answer your doubt. But you do not need to worry about that, I think. Just a minute. Yep. I'll make here. Cyclohexane is there. So you can prepare for this one because they will ask, they may ask this one actually. Cyclohexane. So bad at drawing. Okay. This here, 4 electrons you need to complete for each of these. Okay, let's start it. No, it looks scary. Let me just this. Done. And then you want to complete the octet of these also. Actually, it's a little tricky. 1, 2, 3, 4, 5, 6, 7, 8. It's like this. Similarly, it will have like, actually it doesn't look good though. It looks weird. Let me try it again. Hey, what was your question? I hope so you answered it. Actually, I think you can do one thing. Instead of drawing it like this, you keep the hydrogens as it is, these hydrogens, but in place of this, you add just a line. Just a line, because it will make it less complicated. Okay? So you just make like this, right? And then you show these bonds as in circle like. Okay? For cyclohexane, prepare it, okay? Something like this, okay? So you, for sulfur one, don't worry, they're not going to ask you for the sulfur one because it's not in the syllabus. It is in the syllabus, it is in the book, but they don't ask question about that. Trust me, it's too complicated. See, I tried drawing this, it got too complicated. Yeah, it it looks like a tortoise. Yep, now I see it. Yes. Yes. My name is Ekta ma'am. Why you want to know my name? It's in the description, no? Ayo, it's so bad. Ayo, sorry. Okay, so let's start with the next question. Where is my next question? You have ethanol. If you heat ethanol, add a 5% solution of alkaline potassium permanganate, what will happen if you add too much of it? So my dear students, very simple, very easy. When you have ethanol and you put alkaline KMNO4 to it, it is an oxidizing agent. It is an oxidizing agent. It will oxidize ethanol to ethanoic acid. It will oxidize ethanol to ethanoic acid. Clear? Okay, it will oxidize ethanol to ethanoic acid. Now, once this conversion is complete, this oxidation is complete, what will happen? If you add more potassium permanganate to it, this conversion has already happened. There is nothing there to react with. So obviously, if you add too much of potassium permanganate, it will retain its color. It will be purple colored only. Okay. Next question. Freezes. This is actually ethanoic acid. No. Presence of a few drops of concentrated sulfuric acid with a sweet smelling substance is obtained. You need to tell me. Again, a C. An organic acid. This is an acid. Okay. C, it is an acid. And which often freezes during winter time in cold countries. It is acetic acid. It freezes. That's why it is called glacial acetic acid. It freezes like a glacier, like in this shapes. So it is called glacial acetic acid. Okay. So an organic acid, which is a liquid, often freezes during winter time in cold countries, have the molecular formula C2H4O2. Oh, I know that. This is C2H4O2. C2H4O2, count it. 2 carbons, 4 hydrogens, 2 oxygens, right? On warming it with methanol, if you heat it with methanol, this is methanol. In presence of few drops of concentrated sulfuric acid. This reaction is called esterification. So you will get an ester, my dear students, okay? So from here I told you, right? I told you that H from here and OH from here will combine, and what we will get? We will get CH3, COOCH3. This is the ester, okay? Methyl ethanoate. What is X? What is Y? This is X. This is Y. And this is the reaction. This is X, this is Y, and this is the reaction plus H2O. This is the complete reaction. Okay? If we write ethanoic acid, it's also correct, right? Yes. Ethanoic acid, acetic acid, ethanoic acid is the IUPAC name. IUPAC name is ethanoic acid. Acetic acid is common name. You can use either one of that. That is fine, my dear. Wow. Space. Yes, that is correct. Difference between covalent compound and ionic compound, that depends on the type of bond. Covalent bonds are formed by, covalent compounds have covalent bonds, and covalent bonds are formed by sharing of electrons, right? Ionic compounds have ionic bonds. Ionic bonds are formed by transfer of electrons, right? Ionic bonds are stronger, covalent bonds are weaker, okay? Ionic compound have high melting boiling point, covalent compounds have low melting boiling point. Huh? Yes. No, you did not study you have to add water in acid. You studied you have to put acid in water, that too dropwise. Yeah, that is wrong, Priyanshu. That is not you read, I believe. Because never in any books it is written that you have to add water to acid. You add acid to water. That is dropwise you add. Dropwise you add water to, dropwise you add acid to water. Okay? And you stir it constantly. Done? Now let's move on to the next question. Any other doubt you have, just tell me. Write the molecular formula of alkane, alkene, alkyne, each having 20 carbon atoms. 20 carbon atoms. Okay, let's write CnH2n plus 2, that is the formula of alkane. CnH2n, that is the formula of alkene. CnH2n minus 2, that is the formula of alkyne. So let's write a compound, a molecular formula of a compound that has 20 carbon atoms. So C20H20, 2 times 20 plus 2, which is C20H42. Done. C20H40, C20H20 minus 40 minus 2, 38. Done. This is the formula of alkane, this is the alkene, this is the alkyne. Okay? Okay. Next. Oh, we are done. Okay, my dear students. If you have any doubt, I am giving you 2 minutes. Yes, you have 2 minutes to tell me any doubt you have in chemistry. I will help you. Okay? And if not, then our class is done, my dear students. You can download the PDF again from the description box. Download it. It has all the important reactions. It has all the physics formula. It has all the biology diagrams, right? Yes, what is your doubt? I'm here. I'm all ears. Just tell me what your doubt is. Guide is not good for chemistry right now. If you're starting any new guide, I would say don't jump in that. Okay, what you can do, you already have the notes, right? So revise from notes. Do not even start the NCERT now. From NCERT, solve the questions. Solve the questions from NCERT, revise your notes, solve PYQs. That is important. Do not buy any guide and start reading or learning now, because now is not the time. Electrolysis. Electrolysis is passing of electricity to do decomposition. You do decomposition using electricity, that is electrolysis. So when you pass electricity, a substance decomposes. The reaction you have is water, decomposition of water using electrolysis, or electrolysis of water. In that, if water decomposition of water will give hydrogen and oxygen. At anode you will get oxygen, at cathode you will get hydrogen. You do not have to do multiple resources. You already have notes, I believe, from your school teachers or from our classes. You have the notes, right? Just revise those notes, then practice questions. That's all. Practice questions. From PYQs practice, from sample papers you practice. Online every material is available. Okay? From NCERT book, you have the PDF, downloadable PDF, right? There you can practice questions. But do not start learning now. When we drink water, so when we don't. Wow. Oh my God. Yeah, we are doing, that's nothing like that. We are not diluting that acid, first of all. It's highly concentrated. A little water won't do. And yeah, our stomach has so many more things. It's not just HCl there. It has a stomach lining, then you have mucus there, then you have proteins. There are the other enzymes there, pepsin and amylase and all that. Nothing will happen. You are alive, no? Nothing happened when you add water in your stomach. Okay, I guess your doubts are cleared. Solution we use in electrolytic refining. So the solution that we use in electrolytic refining, any metal you are trying to refine, if you are refining silver, you will make a soluble solution of silver. We use silver nitrate. If you are refining copper, we use a soluble solution of copper, which is copper sulfate. Okay, so any metal you are refining, you make a soluble solution of that metal only. Okay. I guess all your doubts are clear. Butanoic acid is a weak acid because carboxylic acids are weak acids, that's why. Carboxylic acids are weak acids, that's why. And if you increase the hydrophobic part, the hydrocarbon part, CH3, CH2, CH2, right? You increase that part, so the acidity also decreases. Yeah, FF gamer, there will be an explosion, trust me. Which solution? Like acidified something. Name for electrolysis we use acidified water. For electrolysis we use acidified water because water is not a good conductor of electricity. So that's why we add acid. Acid has H positive ions, and these H positive ions will help do electricity conduction, right? Because we are passing electricity through it. Missile formation, go. Okay, so missile formation you want, right? I'll show you. This is missile. So soaps have this hydrophobic tail and a hydrophilic head and a hydrophilic water loving head. Okay, so whenever they see a oil particle, these soap molecules align themselves in such a way that the hydrophobic part is towards the oil particle, is pointing towards the oil particle, and these hydrophilic, the water loving part, is pointing outside towards the water. Okay, this formation is called missile formation. So with that, any dirt particle if you have on your cloth, they will form a missile, and then you wash it away. Firstly you rinse it like this, right? You agitate it physically or using washing machine, and then it get washed away by excess of water. That is missile. Just draw this diagram when you're writing. This is the hydrophobic tail, this is the hydrophobic tail, and this is the hydrophilic head. Okay, my dear class, I believe, where is the pen? Okay, that was it. I hope your doubts are clear. Thank you, you're welcome. Please score good marks. Okay, do not worry. Be chill, okay? Just revise everything you know. Do not start anything new now, okay? Do not start learning anything new now. Calcium doesn't float in acid, it floats in water because of the hydrogen bubbles. I told you, na, when calcium reacts with water, it forms calcium hydroxide and hydrogen. These hydrogen bubbles surround the calcium metal, and because of that, it will float. Gas floats, na, on water. Hard water has calcium magnesium ions, soft water does not have. Hard water have calcium and magnesium ions in it. Okay? Tomorrow morning is the next live. Do join it. Addition reaction of ethene with hydrogen, it's called hydrogenation. Catalytic hydrogenation or hydrogenation only. I hope so. Please revise it. I have given you time, and I've given you enough time to take screenshots and everything. Please go through the notes once, go through the questions once, okay? Oh, thank you. Tomorrow morning you will have the physics live, okay? Complete physics live from by Aditi ma'am. Just join it, and yes, take care. I think. What was your question? Oh, I'm not going to answer that. No politics here. Okay, I guess you don't have any doubt. Notes, I have told you, it is in the description. in the description of this video, in this live actually, you can download it. It is in the description, right? You download it, it has all the notes. Okay, everyone firstly go like the session if you enjoyed it. If you learned something out of it, please go like the session. Second, download the PDF that is in the description, my dear students. It has the important notes from biology, physics, chemistry for your science exam. Okay, do not worry, you got this. And yes, take care. I love you all. Please score good marks in your science exam and all the other exams that are left, language and SST. Okay. Yep. Any doubt you have, you can ask me. I'm just ending it. I'm ending the live. Okay. Yeah, same. I do feel physics is very tough for me also. Any doubt you have, ask me, or tomorrow morning you have the next live class. Okay, enjoy your Sunday. Wow, hydrocarbon are organic compounds that have carbon and hydrogen atoms. Those are hydrocarbons, right? They have hydrogen and carbon. Hydrolysis of ester. You add a basic hydrolysis of ester is called saponification, and that is the only thing that is in your syllabus. Basic hydrolysis of ester, which is saponification. Okay. Thank you, Yuv. I hope each important MCQC MC questions will be go through these questions. Everything is important. Okay, just prioritize metals, non-metals, carbon and its compounds. Study everything. Do not skip anything. Okay, because CBSE has this. It is full of surprises. It is surprising students a lot these days, so don't do that. Hello everyone. Okay, the class ended. Hi Vaishnav, Manu. You have so many doubts now when I'm ending the class. Okay, so anodizing is basically if you have any aluminum object. So what do? You anodize it. What is anodizing? You coat that aluminum article and aluminum object with layers of aluminum oxide, with multiple layers of aluminum oxide, so that the aluminum article doesn't get corroded. To prevent the corrosion of aluminum article, we do anodizing. That is nothing. Anodizing means adding layer of aluminum oxide on aluminum. Okay, adding layers of aluminum oxide. Okay, bye everyone. Good. Oh, I'm not on these kind of things. I don't use, because you shouldn't also, because you have your exam coming just for 1 month. Do not use it. After that, it's there, use it. Thermite reaction. Thermite reaction is when aluminum reacts with iron oxide. Aluminum reacts with iron oxide. We get aluminum oxide and molten iron plus lots of heat. It's a highly exothermic reaction. And that heat is so high that it melts the iron. The iron we get is molten iron, and that molten iron is used to join the broken railway tracks. That is thermite reaction. Okay, I guess all your, that too also, I'm not there only. I'm not on any social media. To pass, what should we learn? Samant, learn everything. What's the problem in learning? You have time. If you start now, you can also finish. Wow. You have the WhatsApp channel link, right? I'm there. You join the WhatsApp channel if you have any doubt or anything. I don't know if you can post there or not, but surely join the WhatsApp channel. I'm there. Okay. Samantha, learn everything. Please don't skip. But I think I've made a video on top scoring topics. So if you're studying, prioritize those topics. Okay. You aim about crossing 70 at least, 60 at least for me. Okay. I'm your teacher. I want you to score good marks. Ah, that is nice. It's in the description. Go there, click on the WhatsApp channel link. I am there in the channel. Diksha Vedantu class 10. Diksha Vedantu class 10. But FF Gamer, you are smart. Then I think you worked hard for pre-boards. Now keep the work, good work going, okay? Keep the hard work up, and yes, so that you finish good marks with good marks in your boards. Thank you, but I'm pretty average. I'm not that beautiful, but yeah, thank you for the compliment. You're pretty too. Okay, you don't have any doubts. I am going to end it. Okay, done. Okay, then all the best for your boards. Do not worry, you got this. And yes, take care, everyone. Download the PDF, and if you have any other doubt, do mention them in the comments. I will get back to you. Yes, have a good day, whatever day is left. Today was Sunday, but yes, wow, you're going to the next live. Okay, all the best, and you got this. Take care. Bye bye.